Check. A warm good morning to one and all. Welcome back to day 2 of SPICE 2K24. We're about to begin our presentation. Before that, let me take the pleasure of inviting our guest of the day. We have Dr. Binu VP, Associate Professor of Model Engineering College, Srikakara. We welcome you, sir. Srijit Mohan J, Joint Director of Chennai Branch BIS. We welcome you, sir. Dr. Ramu A, Associate Professor of Adi Shankara Institute of Technology and Science, Kaladi. We welcome you, sir. Dr. Radhakrishnan B, Professor of Computer Science Engineering Department, MPITS. We welcome you, sir. Professor Bose Joseph, Professor of Practice at MPITS. We welcome you, sir. And let me take the pleasure of inviting our respected principal, Dr. Professor Johnny Joseph. We welcome you, sir. First, we have a keynote address from Dr. Binu VP, Associate Professor of Model Engineering College, Srikakara. Over to you, sir.
Very good morning to all of you, respected dignitaries of the dais, my dear students. I think 2 months back we had a very long workshop, 2 days workshop. I conducted 2 days workshop. How many of you are here? Have you listened to me last time? No. Right. Okay. I think it was for computer science students. Right. So you are all not there. Okay. So it was basically on the 2 days workshop was on machine learning and Python. I had a discussion with Mithun what to talk today. He told most of them are students, so I didn't put much on my slides. So as you know, nowadays it's a trend, like you have computer science branch, suddenly you have AI and data science. People will switch to data science and this machine learning concepts. But to be frank, to learn computer science, it's compared to be easy. And when you look into data science and this machine learning, you will end up with complicated things. That's what really happens. And the student stuff, usually you'll see in computer science, you'll see good students. So these students coming for this machine learning and data science, they're usually low rank students. Okay, so finally they will be in trouble. So, so what I personally suggest those who are interested in machine learning, data science, or any advanced technologies like blockchain. So you make your essential mathematical skills very strong. That's what I suggest personally, especially your algebraic skills, linear algebra, make your probability, statistics, right? And of course, the machine learning, as you all know, it's a kind of optimizations we do. Whatever the model which you see, ultimately our aim is to get a better model by reducing the error. Finally, we'll end up with a optimized model. So optimization and calculus is another area which you should concentrate. When I think of talking, why I put this topic is nowadays we are all talk about generative models. Right? So before starting the generative models, as how many of you are? I think all of you are familiar with machine learning, right? It's okay. If you are familiar with machine learning, I'll tell you the old models, right? I'll put up scenarios so that you can very easily understand. Okay. So the very old model is like you have a regression model, right? What do you mean by regression? Predicting something. So I'll put a simple scenario, you'll understand. I have all your marks. Maybe your 10th mark I have your 12th marks. I have all your previous semester's marks, grade and all. Okay. And the question is, can you predict, maybe you are in 8th semester now, can I predict your 8th semester mark? It's a question, right? So maybe based on all your previous experience, I'll be able to predict your mark in the next semester. So one kind of problem. Basically, we call it as the regression problem, predicting something. And you have a modified version, which we call it as a classification kind, or we call it as logistic regression. Maybe you have a binary classification. The question is, the same scenario, what I can say is that I have all your details. Now the question is, will you got a placement or not? Okay. It's a kind of machine learning problem. Right? I have all your data. I'm putting up a question, and this particular, I'll take all the previous year data, students, all basic details. Then I have the data like student is placed or not. And based on this previous experience, can you able to predict this particular student is going to get a placement or not? So suddenly it become a classification kind of problem, a binary classification. So that is another model which you'll see. And of course, you have multi-class classifiers. You have a classifier problem with many classes. Right. Problem is like, say, how passed students and failed students. When I say passed students and failed students, you have a binary classification problem. Suddenly, I want to grade my students, right? Instead of saying pass and fail, of course, you don't have any grade for the failed students. But passed students, you would like to have a multiple classes, like how many of you are in A plus or B grade, C grade. So suddenly, your problem become a classification problem and into multi-classes, right? Another problem which we will see is the clustering kind of problem, which is an unsupervised kind of learning. So you have all students sitting here. I want to put up all of you into 3 different classes. Right? Right? I can define different classes, maybe according to the, say, for example, some people are wearing this gray color saris. So I make a cluster based on their dress color. Suppose you have student set based on the marks, I can put some 3 or 4 category, very good students, average students. Okay. So here the problem is like, depending on our application, we may end up with doing a kind of classification problem. Why you want to do this? It depends on maybe you will have some typical scenario for a particular class. I want to do that. Right. Maybe I talked about the dress. Say I want to stitch t-shirts for these different classes of students, right? I don't want to take individually the measurements of each students, right? I'll end up with some large, medium, this Excel, this kind of classes, right? Suddenly I will put up a general criteria. What is this Excel class? And I will try to bring in all the students to this Excel class. Then I will, so what I will do is I will finally stitch t-shirts for only the Excel class, right? So some students belongs to this Excel class, I'll give t-shirts. So similar scenario exists for the machine learning problem also. So if you look at all these machine learning things, you have a large data sets, and we try to model the machine, right? And to put it in mathematics, what I can say is that we are approximating a function. Okay. So the entire students details, I can say this student details, one row, the students details, one row. So like that, you have a set of data with several features. Okay, you have a n number of features for the students, and finally, you are building a mathematical function. You can simply say f of x. So what is machine learning? It's f of x, right? So finally, you will end up with a y, which maybe if it is a regression problem, it is a numerical value. If it is a binary classifier, you have a 0 or 1 output. Or if you have multi-class classifier problem, you have a number of outputs. So this is how we formulate this machine learning problem. Okay, so in effect, this how effectively you can formulate this f of x, how you can effectively build up this f of x function so that it will give you the best performance. Okay, so if you have a large amount of data, you can better approximate your function. That is one thing. It's quite natural, right? If you have a large number of data, you have n number of points. I want a function which approximate this, then your f of x will be a better function. Okay. So there are a lot of techniques are there to approximate this f of functions, right? So I told you, ultimately our function f of x is ending up with a probabilistic function. That's certain. If you know the distribution of the data, then your f can approximate data from that particular distribution. Right? So this probability distribution we will discuss today. So a bit of a review now. What are the basic machine learning problems? Usually I do interactive sessions. I'm interested actually in workshops only. We have a regression problem, classification problem, you have a clustering problem, right? You have multi-class classification problem. And today's discussion is none of this. Today's discussion is on to generative models. Right. Nowadays, as you all know, how many of you are using ChatGPT? Yes, all of you. How many of you are? Right. Nowadays, people, I think our researchers are here. Nowadays, research become a very simple job. Right. You can start writing. So there are a lot of tools like typeset.io. Those kind of things are there. Straight away, you can start writing a research paper. Suppose you want a survey, immediately it will automatically it will search for best 10 papers in a particular area, and it builds a survey for you. Right, you don't have to sit and read these papers and write a survey. Okay, so that way your generative models are training into. So I thought of having a discussion on generative model, but I'll not touch upon this text-based generative models, so which are very popular now. We have Bard, have ChatGPT. A lot of things are there. People are using it. Bard is now changed to Gemini. So Google is putting a lot of efforts to build these generative models. Okay, so I thought of putting my discussion on a different area. So we will discuss generative models, especially in the visual perspective. So how many of you have used DALI 3? Not used. Midjourney? No, you have used Midjourney. So these are some of the generative models which can generate images from a text. Right? Maybe you will put up a textual information. So for example, I'll give a information like students sitting in a conference. So immediately it will give a conference hall with students sitting. Right? Or something like you have a, say you have, need a flower with red petals. So the model will be able to generate it. So previously, the problem was to have a data distribution. We are able to place a probability distribution on the data. Now the problem is to understand the probability distribution of the data, and using that, can you able to generate the same data? That's how these models will work. If you are able to understand the probability distribution of the data, then of course you can generate it. Okay. Suppose you have images of say 10,000 cat images you have, and if you are able to understand the distribution of these cat images, especially the probability distribution, then you can start from a random noise and build up this probability distribution. And finally, we will end up with a beautiful image, not exactly the same image, randomly it generates. And you can see my slide, which I am starting with an image, and this person does not exist. Nowadays, the kind of deep fake kind of thing, you can manipulate anything, you can build images of any person, right? You can also look into this site. This site will randomly generate images. So the discussion is how you can generate these kind of images. So the talk will go like this. Basically, we will discuss about the distinction between the generative models and the descriptive models. Then we will give a brief introduction about the one of the famous generative model, which we call it as GAN. Okay, GAN is developed in very recently in 2015. I think how many of you know about Ian Godfellow? Ian Godfellow? No, he is a master of machine learning. I think you might have seen the book of machine learning by Ian Godfellow. I written a book also. So he actually, this is actually based on physics. Okay, so this most of the things nowadays we are building this, bringing in physics into the computer science background. So whenever you get time, you please go through that. This person does not exist.com. You'll end up with a lot of good figures. Okay, this is our discussion. So how we can generate new data instance? This already discussed how we can generate real animals. Descriptive models could tell dog from a cat. So more in a mathematical sense, what we do is in the discriminative models, given some x, we are able to predict the value of y. It's a kind of conditional probability. And in the generative models, we are trying to capture, if there is no label, it's okay. Otherwise, you have a set of cat images. We know that it is cat images, and we are able to generate this probability. So we have some test embedding, and also you have the image. Can you generate this probability distribution? P x comma y is nothing but the conditional, and p y given x is nothing but you are predicting a label. So previously we have a set of data points x, and based on the data points, can you able to predict the value of y? It's a kind of conditional probability, right? This is what, if you look at in the probability perspective, you have two handwritten digits, 0 and 1. And most of the time in the descriptive model, we are trying to find out a plane. If it is a two-dimensional, we are trying to find out a line which separates the two data points. Maybe you studied machine learning, then you'll understand. So you have a set of class, another set of class. Then we are trying to find out a line which separates this. Okay, so in n-dimensional, we generally call it as, and we try to find out an n-dimensional plane. So that anything above that we'll classify it as 0, anything below we'll classify it as 1. And in descriptive model, we'll try to understand where this belongs. Right? Suppose you have a set of data where these data points belong. So in the text scenario, we call it as text embedding. Right? So text embedding is like you have a set of words with you. Then in n-dimensional plane, where these words belongs. Right? So if you are able to find out some features, some associativity of the words, and these n words will go into some places. Right? Maybe you can consider this room. So if you have words like cat, dog, okay, all animal names will concentrate on one point. Right? So you have all car names, it will go in another point. Right? So if you are able to place all the words, maybe you have a I don't know how many words are there, but if you are able to place all the words, depending on the context also, you are able to place it in this n-dimensional space, then your task will be very easy. Right? Because all the animal words will be in one place, all the car names in one place. Right? So we will pull up like this. Suppose you have an apple, it comes in the fruit category, but also it comes in the mobile category. So you should have some attention mechanism where you can drag from. So you should look at other words also, the surrounding words. Suppose the apple comes in a sentence, you look at other words which are coming around the apple, and depending on the context, can you pull this apple word into this fruit category or into this mobile category? That you can easily. That's what most of the generative models are doing. Right? So you have an attention mechanism which will drag the attention of this word and try to pull it. So ultimately aim is to place all this in a probability distribution so that you will be able to capture it. Next. You have internet connection here? Yes. So the real need of this, especially when you look at the generative models, nowadays can generate not only text, can generate images, can generate voice, we can then synthesize languages. So in the healthcare and all, nowadays we have molecular drug candidates to fight the diseases, and you can try the variations. So once you have generative models, you can try the various. And in the machine learning, one of the things is we don't have enough data sets. So you'll be able to augment your data sets with this kind of generative models. So for example, you are doing some training for a machine learning model and you don't have enough sets. Say for example, I want to train a model which identify different species of cats, right? I don't have this cat photos. I cannot take my mobile and go and capture some pictures of the. So what we do is we normally search in the internet. But once the generative models are popular, the generative model itself, we can use it for generating this. Right. So you have a number of data sets. You can augment your data sets with a lot of data. Right. So you can bring in the data representations. Okay. So we talk about how we can generate this model. Okay. How many of you have learned this? Anyone knows about this generative model? No. Don't have a machine learning course? No. So this generative models, especially the GAN model, which we call it as generally we call it as GAN. The model is like you have two models. Okay, one is called the generator, one is called the discriminator. Okay, so I'll tell you the role of the discriminator. The role of the discriminator is to distinguish between the real image and a fake image. Right. So you have a lot of real images given to your discriminator, and also you will have a lot of fake images given to the discriminator. So discriminator will tell whether it is a real image or a fake image. Okay. So we start with a random image. We'll start with a random image and give it to the discriminator. And also we'll give a real image to the discriminator. So discriminator will immediately tell that it is a fake. Right. So we keep on changing the images. Like the generator will keep on generating different images. And your discriminator will try to distinguish between the real image and your fake image. So there is a kind of learning happens. So in probabilistic term, what I can maybe when I talk about tossing the coin, you will understand. Okay. So you have a tossing the coin experiment, and we know the probability distribution of a coin. So you have a coin with you, and you toss your coin 10 times. Maybe you'll end up with the head 6 times. Tail you'll end up with 4 times. So finally, after some several experiment, I will assume that the probability of distribution of this particular coin may be 0.5. Okay, sometimes 0.6. Maybe it's a little bit biased coin. Right? That means if you do 10 tosses, always you will find 6 heads. Okay, that is the final mean of your probability distribution you are ending up with. Okay. Now, the question is, can you generate a model which is resembling to this? Like you have a probability distribution, you know already the probability distribution. You have some 10 outputs are there. And what are the 10 outputs you generate, you will end up with always 6 heads. Can you generate this probability distribution? That is a question. So what we do is, we randomly pick a probability distribution. For example, I will randomly pick a probability distribution of, say, 0.2. And I will generate 10 coin tosses output. So you know that if you have 0.2, you have only 2 heads. So your discriminator will immediately say that this is fake. The original already you have 6 heads. Suddenly I will change the probability distribution of the generator. I'll make it, I'll again put a random one. Say maybe I'll put 0.4. Then discriminator will say that again it's a fake one. It's not good. Again, I will change the generator probability. So I will keep on changing the generator probability. And finally, your generator will be able to generate a probability distribution which matches with your discriminator. Okay. Now, the question is, after this process, your generator will be able to generate this probability distribution. Did you need the discriminator now? No, we don't need it. Right. Now you have the generator which randomly generate this probability distribution. You don't need the coin at all. Right. That's what we are doing it here. Right. You don't need the original image. If you are able to lay in the probability distribution of the data in the image, then you have a random noise with you, generate your image from this random noise. Very complicated mathematics, but this comes with some physics theory, right? Statistical physics and other thermodynamics. But this really works. Right? That's what you had seen in the PearsonDesindexes.com. There are a lot of sites like Midjourney. I'll show you some of the demo which we have done. And this kind of things, this can automatically generate the image. So what is the input? Just simply a Gaussian noise. Right? You have a Gaussian noise with some mean and variance. You give us input to your model, then this model will be able to generate your image. But this model, you should train it. Right? Say you have some set of cat images with you. You have a discriminator. Then you train your model, your generator and discriminator parallelly. Then your discriminator, our aim is to fool your discriminator. Discriminator aim is to distinguish between real image and fake image. And finally, after say, for example, 1000 epoch, we call it as, or some 1000 rounds, your generator and discriminator will do a min-max kind of game. And finally, your generator will be able to generate images which matches with your discriminator, what you are doing. Okay, so that is the real scenario. So this is a kind of training which I already explained. So your training involves, it's a game like your generator and the discriminator. Generator aims to produce samples that fool the discriminator, while the discriminator tries to improve its ability. And the adversarial training pushes both networks to improve over time. This is what we do. Right. This is a simple example I have put. So it's something like, see the dangerous thing. You're able to generate some currencies also, fake currencies. You start with random. Next slide. So initially it looks like a random figure, and you have a real figure. And finally, if the generator training goes well, the discriminator will get worse and telling a difference between real and fake. So finally, your discriminator will not be able to distinguish between real and fake images. And finally, you will be able to generate it. Okay. So this is how the Jan model works. So you have a latent random variable and gives to the generator. And discriminator will take up real data samples, and the generator is output we give it to the discriminator, and discriminator will combine these things. And depending on the condition and whether it is fake or real, we try to. How many of you know about loss functions? No, loss function. Updation. Machine learning models you are not studied. Maybe you know it. Right. Usually we try to update the weights of or the parameters of the model. Right. So you have a real output, you have a fake output. Okay. Or think of a classification problem, or think of a regression problem. You have the actual output, then the training data, you have the actual output, and our model will predict some output. So how will you find the difference between these two? If it is real numbers, of course, you can consider it as a vector. So you have a real set of output, and the output generated by our model, you can find the sum of the square difference. Maybe you will call it as the distance, the Euclidean distance between these two. So that you can take it as a measure for the error. So we generally call it as mean square error. So this mean square error, using the mean square error, what we do? You have the actual output, and you have the output generated by the model. We see the difference between these two, and we try to update the model parameters. Right. So next time, once the model parameters is updated, it will give you better output. So after comparing the output with the original output, we can make a difference, then update the. This is what normally we do, and we call this process as we use gradient descent techniques to update this process. So in the GAN model, we use a different function, which we call it as cross entropy function. Okay. So let's slide. I'm not putting too much of mathematics, very basic mathematics. Okay. So at least you should understand this loss function, then only you can work with your GAN model. Right. So the loss function is like you have a prediction 1, and you know I want 1. I want 1 in the output. Okay, I want 1 in the output. But your model, the model also if gives 1, then what is the error? 0. Right. Actual output is 1. Your model also giving output 1. That means you are perfectly matching with your model output. So that time my error should go 0. So the best function is can write y of I into log of the prediction. Right. So when the prediction is 1, your log 1 will go 0. So the total time will be going 0. Any value which is less than 1, say your y is 1, your log y is 0.5. Then you have a 0.5, which is the difference, right? That means as you approach 1, your log time will go 0. And finally, your total error will be 0. So that is the kind of cross entropy loss function which you are using in GAN. Or any classification problem, you will use a similar kind of loss function. On the other side, when you have 0 in the output, and if you have the prediction also goes 0, then there is no error. 0 and 0, no error. Right. If the actual output is 0 and the prediction is 1, you have an error. Right. So 0, 0, you should get 0. So the term is like you'll take log 1 minus this. Right. So when that term goes 0, then your loss will be 0. 1 minus y. When y goes 0, you have log 1, then there is no error. Right. So this cost entropy function is the brain behind your training process. So what we do is we try to model your generator will be able to generate depending on a probability distribution. We will convert the loss, and on the other side, the discriminator will try to reduce this. Right. So generator, this is a min-max game. It's a min-max game. Your generator will be trying to increase this, and your discriminator will try to reduce this. So finally, what we do is we will end up with the best optimal solution. This is generally we call it as a gradient descent process. If you plot it as a curve, you will see, especially this function will look like this, because your log function, this inverse of log. This is your original log going up. This is the reverse of that. It's coming down. Log 1 minus y is coming on the other side. So finally, what we are doing is we are moving to the local minima of your curve. Right. So if you have a quadratic curve like this, and finally we will end at the bottom level. That's where your error is minimum. So at that point, your model will be able to generate the best possible output. So that's what we do. And this loss function is very important. Not only this I put an example. So how this model is. Why I put minus is, it's something like, so you have a log for, you have a maximization problem. If you put a minus symbol, immediately it become a minimization problem, right? So something you want to maximize, if you put minus symbol, it become a minimization problem. And machine learning, we normally do minimization kind of thing, right? So it's a kind of optimization. We try to minimize it. I put up one more techniques in this, but I'm not going into this. How much time is there for presentation? Okay. 15 minutes. Total time? 10 minutes. Okay. So these are some of the GAN models. So to speak about this model, we normally use, either you can go for a CNN or an RNN, but CNN is the best choice if you're doing with images. So our models are basically on image models. So if you are trying to train your model on images, then use a CNN for the discriminator and your convolutional neural network for your generator also. So both will use convolutional neural network. And finally, we do the training with text embedding. Then your model will be trained, and depending on the loss function, we will update the parameters. Finally, you have a beautiful generator convolutional neural network with all the parameters fixed. And now what you can do is you can give some text embedding and a random input. It will automatically generate images for you. That's ultimately your generative adversarial network will do. Now I'll show you some of the things which you can do. This is the evolution of GAN. Now we can see your this progressive GAN, which is in 2017. It creates very beautiful picture. Okay, so as the days progress, because technology is advancing every day, so you can see that the photorealistic pictures you can generate. Now for the students, I put up a lot of application. You can take up any application from the set of applications which I show, and maybe you can try in your projects, mini projects. Okay. This is style GAN, which everyone knows. You can try various things. And some of the students, I think from QSAT, they have done a very AR VR based. We have some startup there. So you can try some, say you have trying different specs, or trying different shoes, right? Trying different dress, right? You put up cloth. So you can add up styles to an images and see that. Generating animated characters. Next one. All these are generated by GAN, right? So this is the post-guided image generation, which is generated by using GAN. Next. This is this kind of cycle GAN, which say changes, right? Maybe a color images to black and white, and also it transfers the texture and other properties. This you might have seen in your FaceApp and other applications in your mobile, right? You have a face, we generate different, say age people, different gender. Maybe you change to, right? I think you might have seen this in your mobile app. This is what I told you. You can try different. This is Pixel DT GAN. This is super resolution kind of thing. Of course, you have this GAN can be used to enhance your image, right? And you can also use to inpaint. Next one, inpaint is like you have some portion of the image which is missing. Can you redraw it, right? So using the surrounding features, or in mathematics, we say that using the distribution of the data nearby, you'll be able to fill that portion. So diffusion model, I am not touching up. Is there? Yes. So this is the very recent work which I have done, especially with Aldrin Jensen. He's a very good programmer. So he actually is a final year student. So we put it as a service for the people, right? So when we end up with some good project, usually we upload it in. We had some 3 surveys are there. So we have several open IPs. So students also will feel great when their project comes into our website. So this we put it as a scenario like we have started. You can also try diffusion.mec.in. And since our server space very less, we see here the number of images we are restricted to 2, but still you can generate some images, right? Maybe if you are interested. Remember, if you keep on generating the images, our server is taking up, consuming a lot of spaces. So normally don't try with a lot of images, but try with, say, some text you should give, rainbow in beach, some text. And ask you to generate images. So it's a, all these things are generated by our diffusion model, which you have set up. And our model is especially trained on, see, it depends on how you trained your model, right? Maybe I told you about the training with the cat images. Then your model will be good in generating cat images, right? And there are a lot of training data sets are available, like Oxford Flowers data sets are there. So models you can train with a lot of data sets, right? Flowers. Hmm? Zoom. It's okay. It's something like it's a put up a demo. It's there. You can also try, right? Maybe we will also get some hits, like how many people are generating the images using this. Okay. So the images which is So train your model. Maybe if you are interested in generating the images of your teachers, you should train your model with your teachers, right? Then it will give a better, almost trained in a lot of image area. It will give you good images in many different areas. DALI 3, which is by OpenAI. OpenAI ChatGPT, you know. Okay, OpenAI is the core, the company behind ChatGPT. They also have this image generation tool. We call it as DALI. DALI 2 is there. DALI 3, which is the latest trendy one. It can generate almost all image. And Google also. Google Image Gen is there. Google Image Gen is there. They also put up lot of this. Okay. Google say that don't call bad, right? 2 days back they said there is no bad. We call Gemini. So Gemini is the latest AI tool of. Okay, so maybe in future we all talk about only generative models, because you have large text corpus with you, then you can generate anything, right? That's how the text generation is being done. So old models will spend a lot of time. Even I spend a lot of time in training the model. Okay. So how many of you know sentiment analysis? Sentiment analysis, like you have a text, you should be able to identify what is the sentiment of that. Whether it is, say for example, if it is a movie review. Say I collect movie reviews of a particular movie from say Netflix. I collect it from Book My Show. Okay, maybe I collect it from Twitter handle, and based on this movie reviews of different people, I should say this movie is good or bad. So based on the text, can you generate the sentiment of that? Okay, good, bad, or not. So what you should do is we collect all the text, we train the model, and once the model is ready, your model will be able to say that this is good or bad. Right? That's what we were doing. But now you know you have generative models like ChatGPT. You ask ChatGPT, ChatGPT will tell whether it is good or bad. Okay. So that way the models and all changing a lot. Okay. So it's time to look. That's why I took this topic for the keynote address. It's time to look into generative models, especially text generation. Voice generation is also coming up, right? You don't need Yeshudas at all now. You train your model with some of the old songs of Yeshudas, then your model will be able to generate song with Yeshudas sound. Right? You only give input. Input also you can generate from ChatGPT. You ask ChatGPT to give me a song, then you give input to these models, then the model will start generating a voice output with this. Okay, so that way the things are going. And the GPT-4, how many of you used the GPT-4? Not used. All these models are available, right? Many of these models are available for free. You can try these models. Yeah. We have GPT 3.5, which is free, but it's a premium one. You should spend around $25 for GPT-4. Or the institution account is there, a premium kind of thing. You can have a server kind of model. Some people can work together. But GPT-4 can see also, right? You can give a image as input to your GPT-4. Yeah. Yes. GPT-4 can do all data analysis. It can generate all figures. It can understand images. That's very, very important, right? Say, for example, you take an image and ask questions to GPT. It will answer almost all the questions. It will sometimes it will try to give exact place also, right? Say like I'll take a photo of this classroom and I'll ask how many participants are there. Immediately it will give answer. I have access to GPT-4. Immediately it will give answer, and I'll ask how many people are there with sari. It will give you answer. How many boys are there? It will give you answer. Right. Maybe 98% most of the time it's correct. GPT-4 is trained in a beautiful way. And one of the things which I used 2 days back is you give a room photo and ask GPT to reorganize it and give a better view. Right. So say for example, you have your living room at your home, you take a photo and ask ChatGPT how to organize it. You organize things better. So that way your GPT-4 is going, very recent GPT-4. So some of the, our IIT Madras has got this, if you are interested, you can try this. AI for Bharat. Our students should know this. So very, just like your NPTEL, NPTEL, you know, National Program on Technology Enhanced Learning. It's a MHRD project. So we try to, similarly, we had a new project started at IIT Madras. So people are working on Indian languages, models which are trained on Indian languages. It can do almost anything, right? So for example, you give Manglish, it will give you Hindi. You give Manglish and see, I don't know what is how to write Hindi and all. So you can type it in Manglish. Okay. It will. So those kind of models are there. You look at the applications, and there are a lot of applications are there. You can also, these models are free, open sourced, so you can download it. Maybe you are say you are writing an, say for example, you are building a chatbot. Maybe for this college, you are building a chatbot. So what you will do is you should train your chatbot with all the data of this college. Then only if you ask something, it should give the answer, right? So people nowadays, you know, people will do voice search. Right? So you are trying to incorporate voice search in your chat bot. Then you don't have to code it. You don't have to code it. Right? So you can take one of the trained model. So automatically, once you have the API with you, just call the function. So immediately it will convert the text. So most of the things you can use existing models, like I said, your voice to text conversion or these kind of applications. Okay. So there are a lot of models are available. Hugging Face. Hugging Face is a, so I'm a big fan of Hugging Face. Hugging Face. So there are a lot of things are there. Models are there. So the diffusion model and the model which I done a demo, which is built by our students. Our students are making all the interface kind of things and other stuffs. But some of the models we are also taken from this, right? So what you can do is, say for example, the image generation. You have 3 underlying models running, okay, trained by some people. We don't know who trained this, but don't worry. You make another API program, right? You make a new program. So what I will do is I will collect input from the user. I will generate images using this model, and this model. Then I will see which model outputs are good. Then I can combine those things and present to the user. So what I am doing is I'm just creating just an interface, and on the background I will be running 2 or 3 models and generating the images. Okay, so that way you should build. That way the technology is going. So anything to add? Want to ask something? The generative models. I think all of your researchers. Yes. For the researchers, all of you can use. So there was a scispace.io. Now it is typeset.io. All of you can use this. Very nothing to do. Right? Not seen. I'll show you. So this is okay. So this is our scispace. Okay. Say you are interested in diffusion models. See, you don't know what to do. So you can start a literature review straight away. Result from all this. Yeah, yeah. Hello.
Uh, Dr. Beno, thank you very
Yes, yes.
much.
Yeah,
Can you hear me?
yeah, yes.
Dr. Beno, thank you very much for a very enlightening talk. It was very informative. I just have one query regarding what we just talked about. In
Yeah,
the age of deep fake images and the such, how do we combat such problems that arise from, the
yeah, yeah.
use of
The
images of that nature?
yeah, yeah,
Maybe if you
yes.
can talk
Ethical
about that.
issues are there, and nowadays there are a lot of scams also. Right? People are asking money. Maybe on. I think all of you should be very vigilant. Right? Don't post other pictures, etc. on Facebook. Nowadays there is a scam started. One day you will receive a porn video in your messenger. Ask for money. Right? They will say that we will publish this and you should pay some money. Right? You cannot do anything, right? It's very easy, right? You have a porn video, you can do some. I think you might have seen the some of the deep fake videos. Mammootty, Mohanlal, some people have done this. I think one of our students have done. So these kind of things are happening, right? So you should be very vigilant about. So now there is in GPT scenario. How to identify the contents which are generated by GPT. So GPT, they have started a new thing which we call it as. How many of you know about this? GPT zero. So there is GPT zero. Okay, so GPT zero is the purpose of the GPT zero is it's an AI detector, right? Okay, so whether it is human generated or AI generated thing. So if you give to GPT-0, GPT-0 will say it's a AI generated or human generated. But now there are a lot of generated tools which humanize the AI based content. So see the scenario. We have generated tools for generating contents. Now we have tools for humanizing this content. Some people are working on finding these contents which are generated. So GPT-0, in effect, can. So the ethical issues are very, very high, but GPT is a little bit more ethical. So if you ask ChatGPT, uh, can you give me an algorithm for making a bomb? You ask ChatGPT. GPT will not give, right? GPT will not give. GPT will say that this is not ethical. So there is a kind of ethical issue. There is also a social issue. So that's why it put up some. But bias will be there. Bias depends on how you trained your model. Right? Say like you ask ChatGPT who killed Mahatma Gandhi. See, I can frame the answer, right? I can train the model. I can frame the answer. So some people, so the kind of answer GPT gives depends on the model itself, how the model itself is trained, right? So that's kind of bias, right? Maybe true or false. Cannot always depend on ChatGPT. So that's a kind of bias. Ethical issues are there, social issues are there, and this kind of scam is very dangerous, right? 2 days back, I had seen such a kind. One person called me, right? So they are asking for money also, right? Because these things he can very easily make it. Previously, it was a complicated task. Ordinary person cannot make it. So you need good skills like video editing skills. But nowadays, you don't need any. All you need is some money. Right? You have some $50 in your pocket. Subscribe to one OpenAI tool. Right? Most of the tools you will available online. You ask. Okay, so there are People Pal is there, EOID is there. Okay. Uh, Say v.io, right? I will give your face, this particular person's face, and I will give a text. So immediately you can see that this particular person is speaking.
If we are uploading a document and asking GPT to find out any regulatory non-compliances in the document.
Uh-huh. Yeah, yes, yes. So that is used for training. In GPT-4 itself, GPT-4 itself, they will give you multiple answer. So I'll tell you the GPT-4 scenario. I say, for example, you need a program. You need a program. You ask ChatGPT, give me a program maybe for adding two numbers. Right? ChatGPT will give you, GPT-4 will give two programs. Sometimes it will give three programs and ask you to select the best one. Right? So you have some programming knowledge. So I will select, I feel this is good. Usually we select a program which we understand very easily. So we'll select one program. So it's a kind of retrieval augment based training mechanism is
Sir,
happening.
my apprehension is that, so when we are uploading such a huge
Yes, yes,
document,
all data will be
can
lost.
we ensure the confidentiality of the document? Because it's
No.
already been uploaded, isn't
Yeah,
it?
that's gone. Right.
So there's something that the GPT use it for the training,
Yeah,
means inside,
all the documents they will use it for training.
that will be further used for answering
yes.
someone else as well, isn't
Yes,
it?
yes.
So we cannot hold the confidentiality of the
No.
document. in that.
Confidentiality you cannot.
Okay.
So the if you have a PDF kind of document, especially I'd seen KTU teachers so KTU syllabus and schemes are very large PDF document. So from that you'll not be able to identify your computer science syllabus. And say for example, if I ask you what is the CO1 of computer programming, so you should go through all the documents and find out. But this kind of generative models will help you. Say this, you can use this chat with PDF. This is a very beautiful tool. So this is an AI tool. You upload a PDF file, ask any question, so it will give you answer. Right. So for example, I want the syllabus of computer programming. You upload a KTU syllabus into this, then ask, I want computer programming syllabus. It will extract only those portions and give you on the text format. Very useful tool. So nowadays, say for example, you are reading research papers. You can read research papers, right? There is a specific site on reading the research paper, right? So, say for example, you're interested only in abstract of, say you have 10 papers, you want to get only the abstract you're interested in. Right? You had seen SciSpace, right? Generated a literature review automatically, right? It collected the top 10 papers from the diffusion models and generated. So these kind of things, I don't know how will help the maybe teachers are in danger, I'll tell you, but cannot replace a teacher. But very recently we had a conclave on generative AI. So where teachers differ is like how you emotionally connect with your student. Right. So a student cannot go to ChatGPT. Teacher, say your teacher can take a selfie with you. Your teacher can come to your marriage. Suppose you ask a teacher to give me a solution. I want to make a bomb. What teacher should do is the teacher should call the student. Teacher should maybe call his parent, go to his home, ask what is your problem. Okay, so that's only area where so it's teacher is like a mentor. Rest of the things ChatGPT can give. Yes. But in the future, you will see a device which is like your friend. Right? So the future is like you don't see a mobile phone. Instead of that, you will have a handheld devices which you can talk to. So instead of typing, you talk to the device. It will always give you answer. Say next step, say I will ask, I want to go to Model Engineering College. Immediately it will say. So I want to take lunch. Immediately it will say you go to nearby restaurant. It will give you all the names of the nearby restaurant where the foods are available. So remember, it will also look into the reviews and all, right? Right. So you can go to a restaurant by looking at the boards, but the internet-based data, it's like you have the reviews. You have the price also. Some in the Ernakulam and all will also look at the waiting time. How much time you should wait outside. So that way, models are being changing. So what I can say is that the future is in the generative models. So I took a very small topic on the generating the images, but understand the training of these models are very complicated, right? You should spend a lot of time. You need good servers. Okay, if you look at our server at MEC.ac.in, most of the time it is busy, right? You will not see because students will start putting some training data. So most of the time the server is busy. So the colleges can either go for a cloud-based server or a dedicated server. Otherwise, normal laptop and all, you cannot train your model. Right? So if you have some 10,000 images, it will not load, right? You cannot load 10,000 images and train your model. So you need a good hardware to train, especially the GAN models. Okay. Any other question? I think we spent around 1 hour, 1.5 hours. I think all of you are interested in GAN, right? You want some question? No. Okay. If there is no addition, then we will wind up. So thank you for the patient listening, and thank you for inviting me. Right?
Thank you, sir. Your session was really informative about GAN. Thank you so much. So we are running out of time. So we have maximum 5 minutes for a tea break. And after that, you can move to your respective venues immediately after having tea. Thank you. Welcome back. So we are about to begin the presentation. First of all, let me introduce the judges. Dr. Binu VP, Associate Professor of Model Engineering College, Trikakara. Dr. Radhakrishnan B, Professor of CSC Department, MPITS. We invite you to the panel, sir. Once again, I mentioned the rules and regulations. Total 15 minutes, 10 minutes presentation, and last 5 minutes viva. At the 9th minute, we will be having a warning bell. That's it. Thank you. Judges, please note paper ID 2001. I repeat, 2001. Paper title, Cyberbullying Identification in Social Media, a comparison of transfer learning and machine learning method.
Good morning, all. My chess number is 2001, and I am here to present my topic, that is cyberbullying detection, cyberbullying identification in social media through the comparison of transfer learning and machine learning techniques. Nowadays, cyberbullying is a very enlarged crime among the digital world, and we are facing very really high amount of cyberbullying in the digital world. And up to the abstract, cyberbullying detection is a novel application that is we are introducing. Utilization of transfer learning and machine learning is the process to identify the cyberbullying in social networks. We are using many data sets like KNN to identify the cyberbullying in the social media networks. The cyberbullying identification can be possible in many languages and the social media networks. Key features of this model is multilingual support and contextual analysis. We can detect many languages as the cyberbullying in the social networks. It's a powerful tool for identifying the cyberbullying in the social networks. Up to the problem definition, the impact in cyberbullying is very large, and the information and communication technology enlarges, it fuels the cyberbullying in the social media networks. There is many detection challenges in like in machine learning, inaccuracies and user bias. The automated detection focuses on AI and NLP to detect cyberbullying automatically in the social media networks, enhancing the detection accuracy. The research enhances the accuracy in finding the cyberbullying in social networks. Advanced feature engineering enhances the model performance in high rate and ease of identifying the cyberbullying. Up to the literature survey, a comparative analysis of logic regression, random forest, and KNN models for the text classification is the first paper of my literature survey. It contains the BBC News text classification, and it uses logistic regression and random forest KNN comparison to identify the new issues in the text classification. The advantage of that paper is comprehensive comparison and evaluation metrics, and disadvantages are limited data sets, information, and algorithm selection rationale. The next one is impact of smart on imbalanced text features for toxic comments classification using RVVC model. The regression vector classification model is a very useful model, and it have high accuracy in detecting the issues. The advantages are high performance, robustness to imbalanced data, and else. The disadvantages are complexity and computational intensity. The last paper is text features extraction based on TF IDF associating semantic. The paper deals with the enhanced text classification features, and it uses word-to-word model to perform the classification. Advantages are semantic representation and cluster-based feature units. The disadvantages are dependency on word-to-word and increased complexity. The requirements are to the problem are the programming language. We are using Java to implement this cyberbullying detection system, and compilation for compiling we are using Java C compiler, and for execution we use Java virtual machine. The main components are Java virtual machines and Java application programming interfaces. Up to the design, the first part of our cyberbullying detection is pre-processing of the input data. We processes the input data to remove the stop words like the, a, and etc. words are removed using removed at this first phase, that is pre-processing of data. And the next one is candidate generation. We generate the candidate without the stop words like this, a, another words, and it helps to analyze the pattern of that sentence or a word. The next one is semantic relation extraction. This helps to extract the semantic relationship in this word or sentences. And the fourth one is cyberbullying word classification. We use modified Naive-Bayesian classifier for classifying the cyberbullying words. It helps to detect the bullying words, and also it considers date location and other data of the model. This is the architecture of the proposed system. When we the input data is gone through to the pre-processing area, and it removes the stop words, and it develops the words to single tokens, and it will then move to a modified Naive-Bayesian classifier for classification of the sentence or data. It helps to compare the probability of the word which is cyberbullying word or not, that is good or bad, and it classifies the word as good or bad. The methodology is there is we are using two major methodologies to implement this thesis, and first one is modified naive Bayesian classifier, uses synthetic data set for confidentiality reasons. It uses many synthetic data sets like KNN to implement the classification more specifically and accurately. The next one is system model for cyberbullying words. It formulates a system model incorporating incident date and location that is happened the cyberbullying in the social media network. As a conclusion, we can say that cyberbullying detection has to be done properly in the current scenarios, and we have to identify and prevent the cyberbullying, so that we must have a system that helping to identify the cyberbullying in social media networks. Uh, the effective control measures to prevent increased cyberbullying. This model will help to control the cyberbullying, and it helps to prevent the more cyberbullying in the social media networks. Future scope: continuous learning is vital to improve the cyber bullying in the social media networks, because in local languages many of the people are used to bullying another person in the social media. So we have to use the language learning to improve the cyberbullying detection. It enhances the accuracy by addressing ambiguity and sarcasm. Investigate cyberbullying across languages and media formats. And the increased research on cyberbullying actors and factors to improve prevention strategies. The improved researchers can help to prevent the cyberbullying, and it will enhance the model so efficiently and accurately. These are my references to done this project. And questions?
Where is the performance of your model?
Sir, it's not completely finished. I propose this as a theoretical model. I am trying to implement this model to, and I have created a personalized chat box, chatting system to implement this cyber bullying detection uh, for a just like a prototype. And the data processing is not yet completed, so I can include this the actual precision methods to this.
Where you collect the data?
The data has to be uh, entered by the user. Means the user like us uh, has to be input the data that they have like in, that they realizes it's cyberbullying or not.
In the paper, you have mentioned the AMIC data.
Sir, that's another data set to be included in the model, but I couldn't get the full data from the AMIC, so I couldn't include it in this presentation.
Specified about random
Yes.
and in the regression. So we were comparing to that what is the neighborhood processor has provided.
When we move to the neighbor Bayesian classification, it helps to improve the precision and it, sir. Yes, sir. Sir, it can be act more fastly than other models because we can split the probability to a range of 0 to 4. If the probability is between zero point 0 to zero point 0.4, it can be considered as a good comment or a good word. And if the probability is between zero point 0.6 and 1, then it can be considered as a cyberbullying word or cyberbullying sentence. The middle portion of, means the 0.5 cannot be accepted to this probability calculation.
You have decided to do this with the name-based classifier.
Yes, sir.
Question is why you have selected the name-based classifier? What advantage you find there?
When we use naive Bayesian classifier, we can perform the cyberbullying detection in more faster way. Uh, yes, sir. Modified naive Bayesian classifier help to provide the output more fastly than other uh, detection models, and it's more compatible with the machine learning techniques. So I used it. Okay, thank you, sir.
Thank you. Judges, please note, next paper ID 2004. I repeat, paper ID 2004 on the topic Artificial Intelligence and Internet of Things for Sustainable Smart Farming.
Good morning to all. My paper title is Artificial Intelligence and Internet of Things on Smart Farming. My paper ID is 2004. Let us go to the outline. We have introduction and IoT in agriculture, AI in agriculture, and their applications, challenges for smart farming, the results and conclusions. In introduction, it mainly talks about the needs of AI and IoT in smart farming. In 2015, there will be huge demand of food and water, which will not be able to be produced by the normal farmers. It need a high-end technology to produce the needed demanded food and water for all people. And through this technique, we can produce the ample amount of resources needed for the people. And the challenges caused main challenges for which we focus are the population growth, climate change, and resource depletion. And smart agriculture system is an integration of IoT and AI. It combines the applications of AI and IoT in this. IoT means Internet of Things. IoT is the combination of sensors and actuators which will make a device a smart thing, and it will be connected to internet, and it will transfer data and work accordingly. Through smart IoT devices, we can make a smart greenhouse in which smart crops will be cultivated, and the pollination will be done accordingly, and the climate and the temperature will be maintained in that smart house. Wireless sensors are used in such processes. Temperature sensors, humidity sensors, soil sensors, and fluid level sensors. The sensors are used according to their functions. Uh, Precision farming is used for the cultivation of crops according to their need only. Only they needed chemicals, and the needed water level, temperature, all things are provided according to the need. Other IoT applications are livestock tracking, monitoring, and drones for agriculture, current weather monitors. Uh, they are also used in weather applications. The crops can be protected from harmful weathers and humid conditions. Let's move on to AI in agriculture. AI mainly is used as AI works on the human behavior, um, and it is divided into machine learning and deep learning is a subset of AI. Machine learning is a process in which the machine performs decisions or performs tasks or make decisions according to the data it is given. And in deep learning, it works according to the like the neural network of a human being and the algorithms. These are some processes which can be done by AI: data analysis, precision agriculture, weed and pest control, yield prediction, supply chain, market analysis, environmental sustainability, estimating future harvests. The main applications are such. The main challenges in smart farming are use of pesticide in organic farming. In organic farm, we mainly do organic farming to avoid pesticides. So in when we use pesticides, it will not be a organic farming. So we must maximally avoid chemicals. Through this process, we can avoid pesticides. And through urbanization, it will cause a scarcity of water. Uh, when we implement more devices and such technologies, it will make a urbanized society. So it can cause a drought situation, and the cost for normal the technological cost for devices for farmers will be high. It's a challenge for the normal farmers. Um, and then there are also cybersecurity threats since the data is uploaded into cloud. It can cause a scam for normal farmers. The results by using this integration of AI and IoT are we can reduce the emissions caused by other devices, and it can produce a maximum output of resources from this, and it can increase a smart initiative in local areas by other companies, etc. And more technological development will be developed in a normal area. Conclusion that we can provide a viable and economical food and economical resources to the normal people, so they can have the needed resources in their daily life. That's all. Other references. Thank you. This topic normally we have seen that the in a single area we only uses IoT devices or an AI agriculture device. In this paper, we focus on combining both that IoT and AI devices, so we can make this IoT devices. Uh, IoT. IoT is IoT device like sensors for temperature sensors, climate, soil moisture sensors, fluid sensors. They are used to check the soil level, water level, humidity to preserve a plant and to analyze its growth. Uh, by using IoT devices and with the help of AI, we can provide maximum output. Through by giving by making a model with AI, which will be provided the values from the humidity sensors into that AI, and it can accordingly provide the water level needed for that crop. That AI model will be able to generate will be read the previous status and provide a according needed water supply to the product crop. Um, I haven't made a thought about a model. We can use the a model that are available in Google's etc. Like Teachable, Google etc. In which we can provide the data. We have IoT devices to provide accurate chemicals for like substances to overcome that pesticides crops substance that cannot cause damage to the crops, but we have no information. We can provide the accurate information from AI to that devices to um, for the growth of the crop.
Thank you. Judges, please note. Next, paper ID 2005. I repeat, paper ID 2005. On the topic, the potential benefits of physical layer security for 6G security.
Good morning to one and all present over here. My paper ID is 2005 and I'm taking a presentation on the topic, the potential benefits of physical layer security in 6G security. Okay, so let me remind you guys that this is a brief explanation of the paper so that I can take the presentation within the limited time. So let's start. The outline is introduction, objectives, fundamentals, and then finally conclusion. The introduction, the rollout of 5G and upcoming 6G networks. So we all have access to 5G networks nowadays. Previously we had 4G LTE, 5G meaning fifth generation mobile networks. And obviously the next upgrade would be 6G meaning sixth generation mobile networks. And improved security in 5G. Considering the security measurements in 4G LTE, there is significant upgrade in the security of data transmission in fifth generation mobile networks, and then complex application scenarios in 6G. Okay, so moving forward, we will evolve and then we will have to apply these security measurements in ultra reliable, low latency communications, meaning the latency should be low, no delay between the propagation of the communication between the systems. And so the complex application will have to be fast and the security will have to be high. Next, we move on to the objectives. The objectives of using physical layer security is confidentiality. Confidentiality meaning protecting the data from passive attackers or eavesdroppers. Data integrity. Data integrity meaning if the data which is transmitted is modified, it should be detectable. Next, we have authentication. Authentication meaning verifying the identity of the users or the devices. Next, we have availability. Availability meaning no user should be denied the service. Next, we have motivation for considering physical layer security. First, we have stringent latency requirements, meaning the latency should be low, the delay between the communication should be low. So we will have to use physical layer security. Scalable security for IoT. IoT meaning Internet of Things. The proliferation of IoT devices requires highly flexible and scalable security, and therefore we use physical layer security for the rapid increase in IoT devices. Next, we have the quantum computing challenge. With the arrival of quantum computing, we will need quantum secure algorithms so that the data transmitted is secure. We can use physical layer security for that. Next, we have AI. AI means artificial intelligence. With the increasing application of artificial intelligence in our daily life, physical layer security can be used so that the data is secure. Next, we have a brief description of the topic, confidential transmission. The role of physical layer security in confidential transmission. So confidential transmission means protecting the data which is transmitted by us from passive attackers, meaning eavesdroppers. The role of physical layer security is that physical layer security is that it will enable us to transmit the data securely. Next, we have the wiretap coding concept. In wiretap coding concept, consider transmitter Alice and the receiver Bob, and let there be a eavesdropper named Eve. So if Alice transmits a data to Bob and the channel has a certain amount of noise in it, and Eve being the eavesdropper, the data received by Bob will be different to that the data which is accessed by the eavesdropper because of the noise present in the channel. So this is called wiretap coding concept. To enable confidential transmission, we will be needing to transmit the data to the receiver without the eavesdropper getting access to the data. Next, we have secrecy capacity. Secrecy capacity means a maximum reliable rate. Secrecy capacity means maximum reliable rate. If the secrecy capacity is positive, that means the data secured is the data transmitted is secure. Next, we have privacy in secure sensing systems. First, we have privacy versus secrecy. Privacy means keeping the data a secret even from the intended receiver. And then secrecy means keeping the data secure from malicious attackers or passive attackers such as eavesdroppers. Privacy in sensing systems. Privacy in sensing system means consider sensors such as motion detectors and other devices. So these devices will record data whenever they sense a motion, and this data can be used by the companies which produces it to increase the efficiency of their product or increasing the accuracy. So if the data is completely accessible by the company, that means the user has no privacy at all. So it shouldn't be allowed. Next, we have privacy utility trade-off. The graph is shown in order to prove the privacy utility trade-off. So consider a user. If his data is completely private, then the company cannot use the data at all because it will be distorted to them, and they cannot increase the efficiency of the product. And if the data is completely accessible by the company, it means that the user will have no privacy. So as the privacy increases, the distortion also increases. As the privacy decreases, the utility by the company increases, as shown in the graph. Next, we have secret key generation. Secret key generation is present in physical layer security so that it has secure transmission. First, we have secret key generation protocol overview. This protocol has 3 stages. First is advantage distillation, next is information reconciliation, and then privacy amplification. In advantage distillation, a transmitter and receiver will exchange pilot signals in the channel's coherence time. Pilot signals means synchronization. They will both emit a single frequency so that they are synchronized with each other. And then and coherence time between the channel means the time in which the gain is considerably stable. And they will both have correlated observations because they are in synchronization. Information reconciliation means they will pass this observation through source code decoder, and they will get a binary sequence. The receiver will have somewhat an incorrect binary sequence, but he can correct the output by obtaining side information from the transmitter. Next, we have privacy amplification. In privacy amplification, the output produced from the information reconciliation will be very large in length, meaning the binary sequence will be large. If we apply a irreversible compression function such as a hash function, the length of the output can be reduced, and that is the process in privacy amplification. Considerations for SKG success in this protocol: no step should be skipped, so that only then we can consider that the transmission was successful in a private manner, secure manner. And then we compare the reconciliation codes, and if they're both the same, the transmission was successful. Next, we have authentication using physical layer security. First, we have physical unclonable functions. So this can be thought of as a device fingerprint. For example, consider an electronic device. It will have an electronic circuit. During its manufacture, it will have unique parameters such as vibrations, propagation delays, etc. These are called physical unclonable functions. Next, we have localization as an authentication factor, meaning the determining the physical presence of a device can be also used as the authentication factor for this. Next, we have motivation for PLS authentication, meaning the more complex is the application, we will have more secure authentication. Next, we have conclusions and future directions. Role of PLS in 6G. We believe that physical layer security will have a crucial role in 6th generation mobile networks. Next, 6G features, meaning it can be used. 6G will have sensing capability and sub-terahertz range of communication, meaning 90 gigahertz to 300 gigahertz. The quality of security will be high, and then the physical layer security is adaptive in nature, meaning the transmission rate will be controlled according to the data leaked. Next, we have deployment and adoption. Deployment is low currently. We believe that physical layer security will increase in demand in the communication industry. Thank you. Excuse me, 5G? In 5G. I haven't explored that area yet. And 4G, 5G and 6G, or yeah, I'm proposing implementing physical layer security in 6G. Oh. We use multiple authentication factors like mentioned, such as physical and clonable functions and secret key generation. And using localization as an authentication factor. Physical and clonable functions means like every human has a different fingerprint, and each device will have, it can be thought of as a fingerprint for the device. Each device will have unique parameters, and it can be used as an authentication factor, meaning a key that can be used to access the data. So it will be more secure. Yeah, it's not my project, it's a seminar paper. So, yeah. Yeah, we can combine as well as use it individually depending upon the demand or the need of the user. For example, we can use the location of the device as well as its physical and clonable function for the authentication of data. A wiretap coding system. So I am a transmitter and I'll have a receiver. There'll be a person, let's call it Eve. He's an eavesdropper, meaning he's trying to access my data. So if I'm able to transmit my data to the receiver without him being able to access it, then it will be a secure communication. I will be successful. How will the receiver know it? So that's where we introduce the parameter secrecy capacity, meaning the channel will have a reliable rate. And if the secrecy capacity of the channel is positive, then it means that the data is secure. the degradation of the channel between the transmitter and receiver, degradation caused by noise. So passive attacker means wiretap coding concept means if the channel between the transmitter and receiver is affected by noise, the passive attacker will, if he gets access to the data received by the passive attacker will be different to that data received by the receiver. So that is called wiretap coding concept. Yes, sir. Secret key generation. Size of the output. So hashing for that. How I haven't gone deep into that compressible function, hash function. How we will use it. Thank you.
Thank you. Judges, please note, next paper ID 2003. I repeat, paper ID 2003. On the topic, IoT powered blockchain based e-waste tracking and tracking system for smart cities.
So good morning. I'm here to present on the topic, a review of IoT-powered blockchain-based e-waste tracking and tracing system for smart cities. This is the outline. And moving on to the introduction, as in recent times, due to population growth and urbanization, there is an increase in the waste generation, not only in e-waste, and many other type of waste has also been generated. Particularly due to technical advancement, the lifespan of the device has been decreased, which create more generation of electronic equipments, and after the use, it becomes e-waste. And this, as compared to other type of waste, this e-waste contains some specific toxic and radioactive materials, which is harmful for the health of human beings and also the environment. And also, this e-waste includes some storage devices which contain personal details or privacy data, which if it handled in the black market might risk the personal security. So that is an issue. And our objective is to track this electronic device through the entire life cycle from its production till its disposal and recycling. And we need to verify that the purchase and supply of the electronic goods are carried out by only the licensed users, so that no fraud activities took place, and ensure that there is appropriate disposal of the electronic devices, and to arise the data from the storage devices. This is the proposed system. Initially, the manufacturer produces the electronic goods, and the manufacturer also deploys the order management smart contract. And manufacturer, after producing the goods, they publish the details of the electronic equipment such as device name, type, design, etc. on the blockchain. And the retailer purchase these goods from the manufacturer and make it available for the public. And the consumer buy this electronic goods from the retailer, and the ownership details are also changed on the smart contract. And after the use, it becomes in e-waste. The consumer need to deposit in the nearby smart waste bin. And the smart waste bin is IoT enabled, so it can compute the amount of the weight of the e-waste and its type, etc. And whenever it is full, it trigger the waste collection center about it, and the waste collection center collect the waste from the smart dustbin, and it's transported to waste recycling plant through contractors. And in the waste recycling plant, the waste segregation process takes place, and IT storage devices are separated during this phase and is sent to the data destruction facility where the data is completely erased, ensuring security. And after the data destruction, it is sent back to the waste recycling plant and where it is recycled. And after the recycling, it is sent back to the manufacturer for again producing new goods. So this operation sequence, it is implemented on a blockchain where it uses 5 smart contracts: registration smart contract, order management smart contract, and registration smart contract. All the system user, that is the manufacturer, retail, everybody should be a licensed user registered on it, and all of them have an Ethereum address. And this order management smart contract, it is deployed by the manufacturer, and it allows the retailer, consumer, etc. to place order. And this is the general sequence diagram of how the order management smart contract work. Manufacturer deploys this order management smart contract and also display the images and details of this electronic devices on the interplanetary file system. And this retailer place and purchase the order using this order management smart contract. Likewise, the consumer also. And this recycling plant, after they recycled this product, they need to be buy by the manufacturer for producing another goods. They also uses the order management smart contract, and this recycling plant, after recycling the products, they display the images on the interplanetary file system. And the waste handling smart contract is used by the e-waste recycling plants. It is responsible to implement the waste handling, sorting process, etc. And the smart dustbin compute the weight and type of the e-waste. And this bid management smart contract is used by the waste collection center to select the contractors based on the specification. These contractors produce a bid, and based on that, they select the contractors to transport of this e-waste. And this is the general sequence diagram of the bid and reputation, waste and data destruction manager smart contracts. The smart by waste bin compute the amount, and it then triggers the waste collection center, and this waste manager is responsible for it. They allow waste collection center, then with the help of bid and reputation smart contract, they select the waste contractors, and after selecting the contractor, it is then sent to the waste recycling plant. Then with the help of data destruction manager smart contract, the data is erased and it is recycled. Data destruction manager smart contract is used to detect the data destruction unit, and after the destruction, a certificate is issued to ensure that the data is completely removed. The system is written in the smart contract function are written in Solidity language and tested in remits ID. Another cost analysis. Each function in the smart contract has specific gas consumption that is used in Ethereum. Specific gas unit is used, and based on this gas consumption, the cost is calculated. If the gas consumption limit can be preferred by the user, and if the gas consumption unit is increased, the cost will also increase. From this table, it is relevant that this deploying function consume more gas, hence no more cost is needed. And the security analysis, as all the licensed users are only using transacting in the system, the integrity of the data is preserved, and there is not external or internal threats. And this transaction once made cannot be altered, changed. It is completely transferable, and only modified users with the specific functions are restricted. The authorized users can only access this. And moving on to the conclusion, this perform business in a completely secure manner. It is a transferable, it's a transparent manner, and the scalability issue is resolved using the IPFS system, and the solution is practical, secure, viable, and highly dependable. Thank you. The system is completely employed in this blockchain. Based on this blockchain, the manufacturer, everything they do, activities are recorded on the blockchain, making it a transparent system. So we can track the entire life cycle of this product from production till recycling. This recycled products is again used by manufacturer to produce another goods. So reducing waste. After this, as I mentioned in this order waste recycling plant, with the help of order management smart contract, they make an announcement that the recycled products are okay. Then and if recycled images are uploaded on the IPFS. So this manufacturer can then place order with the help of order management smart contract. Yes, reducing the waste after recycling, they display the images of the recycled products on the IPFS. This manufacturer is modifying this e-waste. E-waste is recycled, and this data is also the data privacy. IT storage devices like hard disk, such devices also become e-waste after the use. So it contains some personal or important data. So they need to be removed, otherwise they enter the black market and affect the privacy. So it is removed, and entire things are removed, and it is recycled, and this manufacturer is used to produce the another goods. It's a review paper of my seminar presentation.
Kavya, thank you very much for your presentation. It was very enlightening, and it's a very good initiative taken that we have a lot of challenges with e-waste.
Thanks.
I have a query regarding the work that you've done. I see that you've gone for using Ethereum as your blockchain platform. Am I right?
Yes. Yes.
Is there any specific reason why you decided to go for Ethereum?
And this blockchain, this to maintain the integrity, that is, it is completely transparent, and we cannot make any changes. So no fraud activities could take place in it. So that blockchain is a better option.
Yes, among the blockchain platforms that we have Ethereum, Ethereum Legacy, Tron, Polygon. Have you had a look at any of the other blockchain platforms?
Yes. Here we use this Ethereum based blockchain.
Okay. Is there any specific reason why you went for Ethereum?
For deploying the smart contract.
Yes, but my question is there any specific reason why you went for Ethereum?
For actually 5 smart contracts are used here. For this purpose, Ethereum blockchain is more suitable.
Okay. The reason why I say it is because Ethereum, one of the biggest challenges with deploying blockchains currently is the gas fees, as you rightly pointed out in your presentation. So
Yes.
if you have a look at platforms such as Tron or Polygon, they might have lesser gas fees compared to Ethereum. So as future work, you can also look into platforms such as Polygon and Tron and see if we can reduce the gas fees involved. And this will actually help you to implement the project at a much lower cost. So it's
Okay,
just a
sir.
suggestion from my side, but excellent presentation, and thank you very much.
Okay, sir. Thank you. using smart contracts. S- I'm not going to deep about this. Some devices in the retailers, consumer, etc. They are connecting together in a platform. So please. In this system, there is a Ethereum address is specified to each and user. So we will be transferring this only to the specific Ethereum address.
Thank you. Judges, please note, next paper ID 2002. I repeat, paper ID 2002. On the topic, blockchain for B2X applications and architectures.
Hello. Good morning. My paper title is Blockchain for B2X Application and Architecture. This is the overview of this paper. Consists of objective and related stuff. Next, we move on to the introduction section. Introduction. Experiencing a tremendous change in vehicular technology. We are now going with smart vehicles. Lot of sensors on board, computing lot of data in real time. Thus, there is a lot of data is required for communication. Thus, we need a V2X communication system, vehicle to everything communication. So the vehicle to everything communication can able to implement it so that this vehicle can communicate to in the surrounding environment and make necessary decision towards their path and provide a better transportation path. Next, blockchain can provide a secure platform. If we consider the V2X as a communication system, then we need to interfere the security concern and the data authentication. So blockchain can be implemented.
You want to have a UAV for this purpose? Because places that are hard to
Blockchain enabled V2X promises to revolutionize this transportation. We can integrating those blockchain and V2X thus creates a more secure form of transportation and data authentication towards the vehicles. Let me move on to the objective. These are the main objective why blockchain is implemented in the V2X communication. Thus, these are these points: data security, integrity, decentralization, smart contract, privacy, data authentication, timestamping, data security and integrity. This blockchain requires the technology or combat the technology using a hashing algorithm which will provide the data in a transformed way. Thus, the includer cannot access the data because of these hash codes. Decentralization, it is the main concept towards this blockchain decentralization, which means that we considering peer-to-peer communication rather than scoping for a centralized authority. This decentralization which requires a distributed ledger system that makes all the copies of this ledger or the information are transferred between all the nodes of the network, thus creating a distributed ledger system. Thus, the control of the centralized authority can be minimized. So next, with the smart contracts, it is mainly based on the smart contracts, which mainly implemented by Ethereum. This is a unique factor that makes the Ethereum more popular because of the smart contracts. Smart contract, which means that a computerly executable program, which if a transaction is done, then the smart contracts or the program instructions are kept in designed to execute if if the person is try to make a transaction with them, he provide the necessary services, then the code activates and the amount of information or the transaction is proceeded to the next person's account. Thus smart contract come into play. Next is privacy. The user identification cannot be relieved. It is totally in this blockchain network, the data which is shared by a user cannot be accessed by another person because this identification is not given, because this identification is done through public key, which comes into play. Next is the data authentication and timestamping. Data authentication, which means if we implement the V2X in a vehicle, thus creates the data is required for the communication between other vehicles. So if I send some data, the other person should validate that data, because this data is a valid user is giving this data. Validation check can be done through the blockchain, and timestamping the data can be more accurate. Next, we move on to the vehicle to everything. The vehicle to everything V2X communication includes so many communication structures: vehicle to vehicle communication, vehicle to infrastructure communication, vehicle to pedestrian communication, and vehicle to grid communication. As we consider a vehicle on the road encounters with so much of external appearances such as infrastructures, pedestrians, grids. Infrastructure, which means the road sign units or road sign units, the road traffic signals. All these are electrified equipments which can send the data if there is a traffic congestion, or such related data can be sent to the vehicle using a nearby or data transfer technique. The infrastructure and pedestrians, which means the people who are on the road having smart phones and smart devices on their own, so they can also transfer the data if this vehicle is coming and some related data. Thus the vehicle can go through a low speed if there is a traffic in that area, a person is passing through that area. Vehicle to grid communication, which is very necessary even in the case of electric vehicles. Electric vehicle requires a battery in order fitted in their onboard device, so that they require a energy surge during the transportation. The electric vehicle, which we can say that the electric vehicles involves solar powered electric vehicles. The solar powered electric vehicles during the summer season, it can able to generate more energy, and when in demand, it can send to the grid, the power station, to provide the extra charges towards the grid. So this makes some transaction in there, and in the winter season, this gets revert the charges or take the power from the grid. So there is a communication request. With this V2X communication, we can already communicate with all the external circumstances. Thus, we move on to this concept of the blockchain. V2X is a communication technique, so that it requires a very secure and data authentication factor in order to communicate. This data authentication and security reasons can be encountered using this blockchain technology. Blockchain technology, there are several features regarding blockchain technology. These are the several features regarding blockchain technology: distributed ledger technology, cryptographic primitives, consensus algorithm, Sybil resistance mechanism, game theoretical incentive designs. which means the digital distributed ledger technology, which means this ledger should be in all these persons, and the cryptographic hashing and the other algorithm, consensus algorithm. These are this blockchain related. This is a figure which shows the blockchain enabled V2X, which the blockchain is fit between the physical network layer and the application layer. There should be the blockchain network. Let me move on to the V2X blockchain architectures. There are mainly two architectures: generic blockchain network and which consists of blockchain, Bitcoin, Ethereum, POS, proof of stake network, permissioned network, modular blockchain, DAG-based blockchain. DAG-based blockchain are direct acyclic graphic based blockchain, because it requires parental nodes in order to communicate with the other creating node. The networks targeting IoT and transportation. Thus, we have the architecture analysis. All these all the V2X blockchain architectures mentioned here are not capable for V2X communication in a large vast scale, because of this huge amount of data is need to be processed, and can be compatible within the vehicles, and the server could be possible. Thus, we move on to the blockchain use cases. There are several use cases which the blockchain integration into V2X can make in use. V2X blockchain services, which involves payments, incentives, reputation authentication, data authentication, and timestamping. V2X blockchain application, which and applications, use case analysis. These are the challenges and the research directions: geographically aware architecture, data storage, offline support, Oracle's privacy, and robust blockchain architecture for V2X. Geographically aware architecture, which means requires a compatible and less ad hoc network for this communication. This conclusion overview of the blockchain in V2X, research needs and challenges, opportunities, future perspectives. These are references. Thank you.
What are the challenges associated with the
take the frequency of stuff?
Yeah, so how do you plan on making that? Because
Inverter
inverter will make it the frequency, and what about the voltage?
voltage is little variant, but frequency must be constant. Inverter maintains the frequency.
Frequency will be constant, so the voltage there will be dip there, right? You're told about transformerless inverter. What is that exactly?
In conventional days, inverter use to step down the supply transformer, step up the supply transformer is used. And nowadays, mostly power electronic devices.
Step up the screens, the output side.
Output side.
Okay.
Nowadays, power electronic devices are used for boosting the current and voltage.
Okay.
Instead of transformers.
Okay, and the work you've done is identifying the rating of the MCB being used and the simulation part, right? Protection device simulation part. Okay. And MCB, have you thought about what are the types of MCBs available?
For single phase, mainly AC side and DC side. AC MCB and DC MCBs are available.
In AC MCB, what are the types of?
Single phase and three phase. Based on ports.
No, even more than that. For depending on the use, what kind of current is coming in?
There's a grade A, B, C, like.
Types are different types. Yeah. So which type we have to use?
Mostly use C type for higher load.
It's not about the load, it's the pattern of the current based on the device here. That also you have to review.
This is a final project.
So the types of MCBs also you have to see what types of where it is being used. and what you have to use there. Okay.
Can you take that objective slide? 1 second, objective slide. Objectives. To screen. Does these objectives are in line with the title of your topic?
This is a part of our final year project.
Yeah.
Our project
You
is
are actually proposing something, a safeguarding system for the solar energy generation, isn't it?
Yes.
So what are these objectives then? These are the benefits of a solar system, isn't it? Does it align each other? How do you justify it? Okay, good. I agree that these are all the benefits of a solar power.
Two 2911.
Good morning, ma'am. I'm present.
Next, we have Aishwarya G. Kumar, paper ID 2911, presenting on a literature review on wearable health monitoring devices.
Yes, ma'am. Shall I start? Hello, ma'am. Is it audible?
Aishwarya, can you hear?
Yes, I can hear. Can you? Is it audible, sir? Sir, hello, sir. Is it audible? Hello, is it audible? Hello, sir. Sir, can I start? Is it audible?
I can hear you.
Aishwarya, is it audible?
Is it audible, ma'am?
Yes, yes.
Okay, ma'am. Shall I start now?
Yes, yes.
Okay. Good morning, everyone. I'm Aishwarya G. Kumar. I'm here to present a topic, a literature review on wearable health monitoring devices. So, starting with the introduction, a wearable technology is advancing with low power devices and solar energy integration. It especially features with vital health monitoring and maximum power point tracking for efficient power generation. This involves the applications such as remote medical aid and environmental monitoring. Also, this emphasizes on robust system design, which is crucial for reliability and adaptability. This paves the way for ways where the future uh, relies on wearables seamlessly integrate for convenience and sustainability. So, starting with our first literature review paper, autonomous wearable sensor node with flexible energy harvesting. A wearable wireless sensor node with FEH mechanism is proposed for biometric monitoring. This this FEH means flexible energy harvesting. This FEH prototype is equipped with a maximum power point tracking and PMC, which are
Aishwarya, can you present once more? The screen is not visible.
okay, sir. So now is it visible?
Sir, is it visible now?
No, it's not visible.
Sir, now is it visible?
Ah, yes, visible. Continue.
Okay, sir. Shall I start from the first?
Continue from the last slide.
Okay. So starting with the first literature review paper, an autonomous wearable sensor node with flexible energy harvesting. This paper this is used for biometric monitoring, where a wearable wireless sensor node is equipped with
Aishwarya,
FEH mechanism.
what's the current slide number? You can start from second slide.
Okay. Sir, from the introduction.
From next slide.
Okay. Sir, please. Sir, is it?
Start. Continue.
Okay. So this paper is used for biometric monitoring. This where the a wearable wireless sensor node with FEH mechanism is proposed. This FEH means flexible energy harvesting it is a prototype equipped with maximum power point tracking and power management circuit, which is used by flat and bent PV panels, which are designed on a PCB board. This prototype will be able to operate in self-sustaining mode, but there is a drawback for it, as it cannot be incorporated into other harvesting techniques. So coming to the next paper, modeling and optimization of a solar energy harvesting system for wireless sensor network nodes. In this paper, there are control techniques of SEH system. Pulse width modulation and maximum power point tracking have been analyzed and compared using the MATLAB software. Now, in that, the result shows that the efficiency of MPPT will be much better than the pulse width modulation control system. So it is not extended to various advanced MPPT algorithms like machine learning, etc. So that third paper, energy harvesting technique for Internet of Things. In this, wireless sensor networks are integrated within the IoT systems to monitor processes. Yeah, EH, that means energy harvesting technology. It is an environment-friendly solution that uses solar cells and piezoelectric circuit, which can provide a large amount of energy for the continuous for long time. And this technique depends on the parameters to be measured, and it also depends on its location. This technique only provides a small amount of power, which can be insufficient for constituent IoT device. So that's the limitation of this paper. So moving to the next paper, the experimentation of a wearable self-powered jacket harvesting body heat for wearable device applications. In that, we are using several devices such as pulse oximeter, glucose sensor, and pacemakers. These paper utilizes the human body heat for harvesting. Uh, Actually, it is known as the harvesting human body heat is a promising alternative to power sensors. They are developing 4 different prototypes which fulfills the power requirement of the devices using, and it is more efficient during winter. The power generation depends on several factors potentially affecting the reliability. And coming to the next paper, inertial kinetic energy harvesters for wearables. So as we discuss about the healthcare wearables and energy harvesting feasibilities, the food-based energy harvesting is favored over other locations. It is the bat. This determines about the harvesting potential variability based on harvester placement and the it has several advantages about higher power output, and resilience to working rate changes. So to the next paper, a piezoelectric based energy harvester for simultaneous energy generation and vibration isolation. It introduced about a vibration based single energy hybrid harvesters. It consists of electromagnetic and piezoelectric transduction mechanisms. It consists of permanent magnet, planar coil, wound coil, and PVDF membrane. Nonlinear Nonlinear behavior of the like spring softening and hardening occurs is due to that different acceleration levels impacting resonance frequencies. The harvester yields varying load voltages and power outputs from its electromagnetic and piezoelectric portions. And the next modeling and optimization of a solar energy harvesting system for wireless sensor network nodes. It defines about the WSN, that's wireless sensor network, for as it have only limited battery life. It proposes an optimized WSN for solar energy harvesting using pulse width modulation and MPPT techniques. It gives the simulation results and its efficiency, such as PWM, have only the efficiency of below 87%, where the efficiency of MPPT is around 96%, and this experiment is validated using the PWM controlled WSN setup. This experiment utilizes a ScienceTech 2311 WSN trainer kit and the Generic LM2575 DC to DC buck converter. So a framework for modeling and stimulating energy harvesting WSN nodes with efficient power management policies. It defines about the energy efficient designs and anatomy issues in several WSN networks. By combining energy harvesting and power management technique is proposed in this paper. The energy harvester, the limited energy generation and storage capacity are defined are the main constraints of this efficient power management techniques are emphasized to sustain WSN nodes alongside the energy harvesting, and it offers a high-level modeling approaches and focus on power assumption and energy harvesting through this energy. This provides the high-level modeling approach and gives a high power consumption. To the next paper, ultra low power photovoltaic MPPT techniques for indoor and outdoor wireless sensor nodes. It challenges in healthcare wearables and the need to reduce battery resilience. It focuses.
You have one more minute to present.
Okay.
Just 1 minute.
It focuses on a PV energy harvesting for wireless sensors, and it is an ultra low power MPPT technique simplifies the architecture by additional components. So to the next, this is the design of solar housing circuit for batteryless embedded system, and it have several advantages, and it is combined using maximum power in tracking for non-stationary light conditions, and it achieves around 1 milliwatt power consumption and up to 80% increase in global efficiency. So moving to the conclusion, that combining MPPT technique and STS circuit indeed enhances the efficiency of a system. This synthesis of advancement is crucial in positioning substantial power sources as key drivers for future technologies. The transformative impact on the next generation wearable health monitoring systems is evident and practically in highlighting the practicality and potential impact of innovations like solar powered jacket on healthcare. The successful integration of solar power generation and power efficiency design underscores the innovation in sustainable wearable technology. So these are the references, and thank you.
this, can you just explain the objective of the study, literature study, what you've done?
We are trying to understand. We are trying to understand the future scopes of wearable devices, health monitoring devices.
The scope, or you would elaborate on that?
Sir?
Future scope means how do you, can you elaborate on that?
Yeah, means by such the several devices such as pulse oximeter, blood pressure sensor, and several such health monitoring devices can be combined in one wearable device. That is, either it can be a jacket or any other belt, etc. Any one of the combining any one of the wearable device. Wearable.
Okay. Okay. Thank you.
Thank you. Thank you, sir.
You can stop the presentation now.
Okay.
And its structure and the materials used to build this capacitive touch sensor. The touch sensors are used, or the touch screen are used to transforming the display from one-way communication to two-way communication. These are the types of touch sensors available now. That's are resistive, capacitive, surface acoustic, infrared, optical image, acoustic pulse. So among this, at the present time, capacitive touch sensor is widely used. So why capacitive touch sensor is widely used? Because of its durability, high sensitivity, responsiveness, touch accuracy, and multi-touch capability, thin and sleek, and it can be process feasibility also considered. So how a capacitive touch sensor work? Capacitive touch sensor, as the name suggests, it's like a capacitor. This has a two-layer transmitter and receiver insulated by a layer. So an electric field is applied. When an AC supply is applied to the transmitter, an electric field is there. So when a finger of a human or a stylus is near to that, it interact or interfere in the electric field. So thereby we can sense the touch. So these are the types of capacitive touch. So there are broadly classified into two. One is surface capacitive touch and projected capacitive touch. And the projected capacitive touch is again classified into two, self and mutual capacitive touch. So on talking about the surface capacitive touch, as you can see in the image, there is a single conductive layer separated by insulator. The AC asynchronous voltage is applied to the four corners of the conductive layer. So there is an electric field in that. So when a human finger, it's conductive, right? So it can interrupt or intercept the electric field. So the touch can be determined by checking the capacitance of the four corners. This is usually used type of capacitive touch. The another one is projected capacitive touch. Um, uh, the previous one, the surface capacitive touch is using a single electrode, but here a patterned electrode layer is used. That can be classified into self and mutual. So, on talking about self capacitive touch, as we can see here, is connected to an XY grid. So, XY grid electrodes are connected, and it's by electrodes are connected by fringing of electric field. So, when the finger touches here, we calculating it is connected to a controller IC. So, determining the touch by using the XY grid. But in this model, there is a problem. If we touch both here, uh, it cannot be determined where the touch occurs. So it is called ghosting. To overcome this problem, the alternative of self-capacitive touch is shown there. So each individual electrode is connected to the IC itself, and the IC determines where the touch occurs. So this is the mutual capacitive touch. In here, the electrodes are interconnected. So the electrons are connected electrically fringed. So as we can see here, it needs a number of transmitting and a number of receiving electrodes. As we seen in the previous one, it's connected in a grid. So as compared to the mutual capacity, as compared to that, mutual capacitive touch is bit complex and it's power consuming because each of the electrode need to transmit and receive, and this data is connected to the controller IC, and the IC senses where the touch occurs. So it is capable of multi-touch, and the structure is the second topic. Structures are classified into out-cell and integrated touch sensor, and integrated one is classified into on-cell, in-cell, and hybrid cell. So talking about the structure as out-cell, this is a structure of an integrated display and touch included. So as we are using the mobile phones, right? The touch sensor are placed above, and the display part is below. Is called out-cell. Almost like now the iPhones right now are using this. This is process feasibility high for this model. But compared to the integrated touch sensing, first one is on-cell. Here we can see that the touch sensor is placed above the display, that is OLED layer, and the major drawback of this system is the visibility, and it can certainly the light are coming out, it can block in certain way. The second one is in-cell. In-cell means the touch sensor is placed beneath the display, or the one it is used to reduce the layer. The receiver layer is integrated with the TFT, that is thin film transistor layer. So we can reduce the size of thickness of the display and touch. Also, the visibility increases because this is under the display. So this combination of in-cell and on-cell is hybrid cell touch sensor. As you can see there, a receiver part is integrated in the TFT layer inside, and the transmitter is above the display layer. So as compared to on-cell, there is that a number of layer is decreased on top side, so visibility is there. So these are the summary of this structure, and among which we can see that on-cell perform well in process feasibility, image quality, and thickness. Still, we are using out-cell because in major phones, but on high-end phones, the touch sensor are integrated to the display, and it is used at on-cell or in-cell model. The process feasibility is the burden to in-cell and hybrid model. Looking onto the materials, there are ITO, silver nanometers, metal mesh, carbon nanotubes. ITO is most commonly used. The major drawback of ITO is it's brittle. We are using the phones, it have ITO layer coated on a glass substrate above the display. And this is silver nanowires, and it is also used as a, it is emerging and it can be used in a flexible display. ITO is brittle and it cannot be used. Metal mesh is also emerging and it has a high potential in using flexible display, and it can be based on plastic layers, that is flexible one, and it is flexible. And this is graphene. Graphene is this processing is too hard, and it cannot be processed as much as easy. So it is needs so much improvisations. Also, the carbon nanotubes and conductive polymers also need to improve in their process feasibility. So this is the overview. As I mentioned, ITO is silver nanomer and metal mesh is comparable with ITO. Graphene and carbon nanotubes is need enhancement, but conductive polymers need to research more to the commercialize. This is the conclusion. We deal with the all parameters, and touch sensor structure and thickness need to be improved, and cost and manufacturing are the burden to making flexible displays and the materials availability. Display quality while using these kind of transparent materials is research and need improvements. These are the references. Thank you.
Technologies which are currently being used in the smartphone world.
So we know that late 10 years back, the commercial phones are using 12 years back. We are using resistive touch sensors. Now we are using capacitive touch sensors as commercially as well. The displays, the phones we are using as all capacitive touch sensors.
I mean, your focus is on the layer arrangement or on the material used?
Overall, about the capacity, flexible touch sensors for flexible display. So nowadays, capacitive touch is most feasible and widely used. So on taking on the aspect of capacitive touch, that material is used and the structure that is used to build these flexible displays are being discussed.
So you're focusing on entire thing.
This is a vast topic and the time limitation costs.
Can you cite the three differences between a capacitive touch and integrated?
Sir?
Three differences.
Sir, capacitive touch is used here.
Yeah.
I'm talking about the topic capacitive touch. First, I differentiate what types of capacitive touch are there.
Okay.
Second is how the smartphone industries are using the structures, how the touch sensors is placed in the display.
Trying to say that the integrated touch one is one of the capacitive touch. Isn't it?
Yeah.
Okay, fine. How many layers are in the integrated touch? How many layers? Number of layers?
As it depends, as the
Integrated. Yeah.
These are on considering only on the figure we can say that, because we are dealing with the touch sensor only.
Okay.
There is for touch sensors there will be 3 layers. One is a transmitter, that means 2 conductive layers and an insulator in between. So in this aspect, that this figure shows that our phone is with a display and a touch integrated inside that, a thin film. So there is number of layers.
Yeah.
So
Yeah, that's fine. Out of the different variants you listed here, probably the material variants as well as the technology variants, which is the most sensitive ones? Most sensitive. or the one gives the most faster response? Faster response. And dot one side. Bullet point, sorry, star. That's all.
So we have two aspects to study.
Yeah.
One is about the structure. So on talking about the structure, outside and on-cell structures are above the display. So as I mentioned that there is an electric field from the touch sensor.
Not going to that complexity. Which is the most fast responding ones to your touch? It's all about the touch thing. Which
Okay.
variable?
Outside and on-cell structures are most responsive, and on compared to the materials used, on that now ITO is a comparison graph. You can see here that silver nanowire has the resistance and transmittance power is described here. So among that, silver nanowire is as having high response.
Okay.
But
Yeah.
now we are using ITO films. Indium tin oxide are usually in this point. This is using indium tin oxide.
That's fine. We have time constraints here. Okay.
Responsiveness depends on the it is processing, right? We are using a chip to control this, to determine this, and the refresh rate depends. We know our phone has 128 refresh rate, 68 refresh rate, touch response. So these factors depends the touch accuracy and response. Thank you.
Good afternoon all. I'm Basil Paul, and today I will be going to introduce you to the topic wastewater management in real time using IoT devices. These are all the contents that we will be going through today. As an introduction, let me just say that the wastewater management is an utmost thing that we need to take care of in our day-to-day life. The overall when we take the overall surface of the earth, mostly 71% of the earth's surface is covered by water. To our surprise, only 96% is in the oceans, and it is in the form of salt water. And human beings cannot even do anything with the salt water other than making salt out of it. The rest 4% is only the fresh water available to us. Within that 4%, almost 70% is in the form of glaciers and ices. That leaves us with approximately 1.8% of fresh water usable to humans. So managing that, making the utmost out of that 1.8% is the key factor that humans need to consider while going on with their day-to-day life. So to improve the water quality and manage the wastewater management, certain things needs to be considered. The wastewater management is important in improving the water quality and the consumption of water which are humans using needs to be considered. While doing the wastewater management, we are also indirectly helping the aquatic life and protecting our environment also. The current scenario that the wastewater management systems is using is manual monitoring and sample. This is not that feasible way. If at all a wastewater, a poisonous substance has leaked into the surface, only after getting certain news, expert has to go to the certain fields to take the samples and collect, and then only give appropriate preventive measures to cope with that wastewater treatment, and it also has certain defects such as limited reporting times and the lack of autonomous controls. We cannot autonomously control the current situation. While looking to the current situation, the problem that I have found is that wastewater pollution is a serious cause, and there are the treatments in challenge overcoming that defects. Biological treatments also have certain challenges. The pH and the temperature of that system has also need to be considered, and there are certain security concerns also in the IoT platforms. So, as the objectives of this project is to implement a cloud-to-device interface and an authentication system to authenticate the users, and the management of the current incoming data and outgoing data needs to be managed, and reverse things also needs to be considered. A cloud-to-user frame also need to be considered. As a system overview, these are all the components that needs to be implemented. A data collection network needs to be implemented. Certain nodes needs to be implemented on various sites to keep track of the wastewater going into the rivers or other sources. A web server needs to be integrated to integrate all the data coming into, and a centralized server needs to be implemented, and a warning system needs to be implemented to alert the authorities or other government officials. The valve after implementing after all these systems, autonomous control needs to be needs to be implemented using autonomous valve control and other things. Government actions are I have already said. This is the flowchart of the system. We start the process and we read the data from all the nodes present in the river. We currently display the present data, and if a wastewater is detected, it closes the inlet valve of the poisonous substance coming to it and sends an alarm to the authorities, and simultaneously alerts a voice alarm also. If the Wi-Fi is not established in the system, it goes to the GSM-based communication and sends the data. And if Wi-Fi is established, it is just a matter of time to send the data over to the authorities. The components that we are using is a Node MCU because it has a onboard microcontroller chip and a Wi-Fi board also. So TCP/IP protocols can be easily implemented. A SIM GSM module can also be implemented to if the Node MCU is not responsive. The one-wire transmission, that is a temperature sensor, the DS19320. It has a temperature sensing functionality of -55 to +125. An analog pH sensor is used to measure the pH values of the wastewater. The ADC is used to convert the analog values of the pH sensor to a digital one. The software components are the Arduino IDE to program the Node MCU. The Visual Studio is used to develop the web and the IoT dashboards. The IoT clouds, we are creating a custom IoT using as AssetNet and the PHP pages. A custom IoT is developed to increase the security of the overall system. There is the HTTP page is created using REST, and IoT gateway device. The three main actors of that RESTful HTTP is the IoT gateway device, RESTful HTTP server, and the database. They request and send the request data and sends the data over with the nodes connected in different areas. The SMS service is there to provide apt message transformation between authorities. The data analysis and the reporting service shows a graph of the if a wastewater has been detected or not. These are the future scopes of the project. Machine learning integration can be also be included to automate the valves and other. As a conclusion, a small economically feasible node has been created to effectively manage the wastewater. These are all the references that I took. Thank you.
So the aim of the paper is to implement monitoring at which place actually? Where do you want to implement the water quality monitoring?
There are many plywood areas, plywood companies which give poisonous substance into the rivers like Peribawar. There are many plywood companies, they just dump industrial waste to the, and it causes a lot of trouble. So on that river, where they dump and where the water flows downstream, on the dams downstream, we place these nodes.
Okay. Can you go back to that flow chart which you have given? No, that flow chart. Thank you. So here you have given a send alarm SMS to supervisor. It's a down. Is it right? The flow chart.
Send alarm.
No, the down you're writing close in that wall. Send alarm SMS to supervisor. And right side also is going and saying.
At the same time, both of them are working simultaneously.
So here, how the alarm SMS goes to supervisor? After inlet valve is closed.
Inlet, there is a SIM module, GSM module also placed in between. The SIM module takes care of the SMS. Node MCU just alerts the SIM module. SIM module gives the messages to the.
Okay, so right side that flowchart, what relevance it has?
That is taken care of the Node MCU, Wi-Fi and that other GSM module.
If the both branches is alerting the same people or same supervisor or
same supervisor.
Fine. Okay. What is SCADA? SCADA.
Supervisory Control and Data Acquisition.
Okay. Can you say that who are the authorities, regulatory authorities to control the cleanliness of the water in a geographical premises here?
I haven't looked into that. Many local areas have somewhat of.
It is basically LSGB. So we say Panchayat or the
Panchayat
municipality. So probably this alarm is actually has to alert them, isn't it? And they have to take the necessary corrective action.
We also close the inlet valve of the company which dumps the poison. So that is taken care of first, and only then alarm center.
So basically, you are proposing a system to automatically alert the competent authorities whenever the river is polluted, isn't it?
Yes.
And to take the corrective action. Right.
That was the last presentation. Winner will be announced and prize will be given during the valedictory function. So everybody is directed to have lunch and assemble at APJ immediately. Thank you. Let me thank
Hello, sir.
Hello, good afternoon, sir.
Hi, good afternoon. Can you hear me?
Yes, it's audible, sir. Sir, can you test your PPT? Can you just
Okay.
share your PPT?
Yeah, can you hear me?
Yes, yes, it's audible. And your PPT also is visible.
Okay, I just want to see if I can put it into full mode.
Okay. Sir, this is not full mode. It's just.
Yeah. I'm just going to go and put it onto full mode.
Okay. Yes, now it's full mode.
Okay.
Okay,
Right.
sir.
Whenever you're ready, you can tell me. I'll start.
Yes. Yes, sir. Yes, sir. Okay. Thank you. Sir, this is not full mode. It's just, Hello, sir.
Yes, I'm here.
Sir, can we start?
Yeah, not a problem.
Okay, so we'll
Are we
start.
good?
With we can
Okay.
start with the introduction. Okay, sir.
Good afternoon, everyone. Now, I welcome Dr. Ranjit Kuriakose, Professor, Central University, Free State, South Africa, for the keynote address.
Thank you very much. I hope I'm audible and visible.
Yes, sir.
Right. Thank you very much for this opportunity. Before I go into my presentation, I'd like to thank the organizers of the conference today. It's a very special occasion for me because firstly, I hail from a town very close to where MBITS is. I come from Unal. So I'm very proud of the fact that I'm able to stay such a long distance away from Kodamangalam, but still be part of this occasion that is being organized by MBITS College. Secondly, I have a very close association with the college in that one of the founders, Professor P.M. George, was my uncle, and I've had a lot of opportunity to spend with him during my formative years. So to actually speak to you from this venue where he has given a lot of his life to, I am very much pleased to be part of this. So in saying that, let's get directly to the presentation that I'll be making today. So I'm just waiting for it to open up. I hope it's opened up now.
Yes, sir.
Right. Thank you. I'm just going to put it into full screen mode. So as rightly introduced, I'm Professor Ranjit Baby Kuriakose. I am going to make a presentation on the role of engineers in achieving sustainable development goals. And I'm looking at it from a smart manufacturing perspective. So this will be the contents for today's discussion. I'll give a brief introduction of the university that I come from, then a brief introduction about myself and the research that I'm doing. Then we'll delve slowly into the sustainable development goals, and I'll focus on sustainable development goal number 9 and how we went about as a university in achieving some of the targets that are set out by the SDG 9 goal. I'll conclude by looking at some of the other SDG projects that we are busy with, and then we can have a discussion if time allows. Right, so I'm based at the Central University of Technology in Free State. It is in Bloemfontein, which is in Central South Africa. This university has 4 faculties and close to 16,000 students. I'm in the Faculty of Engineering, Built Environment and Information Technology, and in the Department of Electrical, Electronics and Computer Systems. So just to give you a map idea, most of you might be familiar with the bigger cities such as Johannesburg and Cape Town or Durban, but we are from Central South Africa. The town is called Bloemfontein. These are some pictures of the university campus that we have. Myself, I am an associate professor in the department. I specialize in control engineering. I'm also the project leader in the Center for Sustainable Smart Cities, or CSSC as it's called in short. And my research focus is on smart manufacturing and industry innovation. Currently, I'm supervising 1 doctoral student along with 2 master's students as part of my postgraduate supervision. I've completed supervision for 1 doctoral student and 3 master's students. I've got a few publications, mainly in journal articles, as well as some conference attendance. I've been funded by external agencies in an amount close to 45 lakh rupees in Indian terms. And I'm also having international collaborations with Aarhus University in the city of Aarhus in Germany, as well as Aalborg University in Denmark. So that's a bit about me. Now, this is some of the research indices that I am currently possessing. I have given my Google Scholar as well as my LinkedIn profiles in the beginning of this presentation, and I'll share it with the conference organizers so you can go through them at length. Right, so now coming to the main topic of our discussion, we'll be talking about the Sustainable Development Goals. So these were a set of goals that were adopted in 2015, just to give a brief background, by all 193 United Nations member states. The idea was to ensure that we ensure that there is sustainability going forward, peace and tranquility among the people. And as part of this, they set out 21 agendas called the Millennium Development Goals. They subsplit that into 17 goals, 169 targets, and 230 indicators. So like I mentioned, the idea is to have an integrated and universal inclusive platform which leaves no one behind. So based on that, we have 17 SDGs. You can see on the screen here that they start from SDG goal number 1, which is to avoid poverty, going all the way up to SDG number 17, which is partnership for the goals. So each of these SDG goals, they are subsplit into targets and implementation means, which are then assessed on an yearly basis to see what is the progress that we are making in this regard. So as of 2023, this is the progress chart for all 17 goals. So if you have a look here, we'll see that the green is an indicator that the goals are on track, while a yellow section shows that they are moderately or severely off track, while a red indicates that there is stagnation or regression as far as the goal achievement is concerned. So if you have a look here, very few of these goals have got a green bar which is exceeding the yellow or the red bar, which means that of the majority of the 17 goals that we currently have, we are in fact struggling to reach forward in those. But luckily, we'll see if you look at goal 9 is among one of the better performing goals. So our focus is going to be on goal 9, which is on building a resilient infrastructure to promote inclusive and sustainable industrialization and foster innovation. So this is the report card for the SDG goal number 9 at a glance. So you can see that like in all other SDG goals, there is also a bit of struggle with the global manufacturing sector slowing down to around 3.3%. This is mainly owing to the COVID-19 pandemic that we entered into, as well as some unrest in the different parts of the world that is slowing down the manufacturing sector. However, there are some indications of how we can actually climb out of the rut that we are in and actually move forward. So if you have a look at this specific section here, which talks to strong growth in 2022, it says that medium to high and high technology industries experienced very strong growth when it comes to manufacturing. And if you couple that with the last statement here, which says that at the present moment, 95% of the world has mobile broadband access, that is 3G or higher access. So when we couple the two together, albeit we are facing some challenges, we'll see that there is a scope for growth and development as far as SDG 9 is concerned. So what are some of the outcome targets of SDG 9? So SDG 9 has got 5 specific targets. The first is to develop sustainable, resilient, and inclusive infrastructures. The second is to promote inclusive and sustainable industrialization. The third is to increase access to financial services and markets. Number 4 is to upgrade all industries and infrastructure for sustainability. And 5 is to enhance research and upgrade industrial technologies. So you'd see that I've highlighted target 9.4 in red here. That is because of these 5 targets, this is the one that me and my team have focused on, right? So we've set out the target. I've explained how the target will be achieved. Then what are the means of implementation of these targets? So 9.A, that is the first target, facilitate sustainable infrastructure development for developing countries. Secondly, support domestic technology development and industrial diversification. And finally, universal access to information and communication technologies. So as a means to implement our target, which is to upgrade all industries and infrastructures for sustainability, we have chosen the universal access to information and communication technology as the implementation means. So now that I've gone through the introduction of what the SDGs are, let us look at how we can achieve a specific SDG. So there are some steps that we formulated. We also looked at documentations from the United Nations with this regard. So the first of these is to think global and act local. Identifying a challenge in our locality, doing an extensive research into how this challenge is tackled globally, then localizing a solution which is most suited for our region or the community or the environment while keeping in mind the cost and effectiveness. Then developing a prototype or a simulation, and finally exploring the market to see if you can get a buy-in. So this is almost like a blueprint that has been proposed, and that one which we abided by to set about achieving the one of the targets in the SDG goals, right? So now we are going to look at how we got into SDG 9 and how we tried to implement it from our side. So our idea was to develop a smart water bottling plant. So we worked in parallel with our management faculty, where we did the engineering side of it and they did the financial side of it. So one of the reasons why we went for the water bottling plant is to allow for sustainable water production. Now, the name of our city is Bloemfontein. So fontein in Afrikaans means fountain. So there is a natural spring that is situated on the campus. So the idea here was to use the natural spring water to create a bottling plant. So I'll just run a short video of how the modeling was done. Let me see if I can play. I hope the video is playing. So we were able to list out each of the components that's needed. We did a thorough financial study. So you'll see that there are some stickers next to each of those blocks that shows what is the manufacturing cost for each of those parts. And then we were able to create a 3D model based on the CAD model that we had, so as to visualize how this water bottling plant will look like. So that was the first part of conception. So we went from a CAD model, and then we developed a 3D model, and we did a feasibility study to see if this would indeed be profitable. But since then, we moved on. Then we decided that we will now need to go on to the engineering side of the design. So a part of my doctoral study involved the development of this smart water bottling plant, although my focus was on optimizing the production of the plant itself. So here you'll see how we went about going through the work. So it was a pleasure of mine to listen to quite a few of the presentations that were made during the course of the day. So this is how I went about developing my project, and also then opening avenues for the team members in my group to further their research on. So we did a very thorough literature review. These are some of the papers that were published in that regard. And then we stated our methodology. We did some research analysis. And then once the paper was, the project was developed, we looked at what are the different ways in which we can extend or develop the project. We will be discussing that at a later stage. But this is a pointer on how we went about doing the engineering side of our work. So then it got to the point where we needed to now start building the unit itself. So our water bottling plant, which will be discussed later by my colleagues as well, consists of a water filling unit, an assembly line, as well as a capping station. So here you'll see the tank. It is a miniature version. So it is a prototype, or an extended prototype, if you want to call it, that we've developed here. So these are the three hardware units that we had and that we integrated together. So the water filling unit and the assembly line are driven by PLCs, while the capping station is run using a Festo arm, which is used to cap the different bottles. So once the physical system was set about, we then went about designing what is known as a digital twin for the very same. So here what we did was we integrated sensors to the different units. So you'll see that there is a flow rate sensor and an ultrasonic sensor which is connected to the tank. Then there are IR sensors which differentiates between the different bottles that we have. And then the data that is collected from this sensor integration unit is then processed on MATLAB. And finally, we use that for monitoring. So we can monitor elements such as the net production time, the efficiency, the cycle time, and also we can monitor if ever there will be bottlenecks or if there will be constraints that will delay a production process if we get to that. So this is the development of the digital twin. So this is just to elaborate on the data collection. So there are some sensors that are connected to the tanks, as well as the flow rate sensor, which is into the water, as well as the IR sensors, which will be able to differentiate between the different bottle sizes. Obviously, 500 ml bottles will be slightly taller than the 330 ml bottles, so there will be a height distinction. This is the data processing, just one element of it, where we're bringing together all the data, and then we were able to then monitor. So this is done on ThinkSpeak, which is a cloud platform. It currently monitors the flow rate, the number of 330 and 500 ml bottles that are being bottled, as well as the amount of water that is left in the tank. So this is all on the cloud and can be monitored at any given time. Right. So this is how the water bottling plant looks as of now. The picture on the top is a larger scale view of it. I have a video here that I want to play that quickly demonstrates how the device will work. So I'm hoping it is playing now. So it reaches the water bottling station or the filling station where the water gets filled into the bottle. And from there, it goes to the capping station, which, like I said, is driven using Festo arms, where we programmed it to identify firstly what kind of a bottle it is, and then do a cap adjustment so as to do the capping of the bottle. So as you can clearly see here, this bottle, whoever gets it will feel a bit hard done by, because it seems like the water bottle is not full. But that is engineering, and that is research. There are sometimes that things don't really fit in or work out completely. But that is basically the operation of the plant. Right. So where are we standing at the moment? So we started off by looking at smart manufacturing, angling in on the SDG 9 goal. And at the moment, we have 5 branches that we are using for our study. So the first is what I was focusing on, that is assembly line balancing and optimization. I completed my doctorate in that topic or niche area. Then I have my colleague, John Kotzer. Dr. Kotzer is working on human-machine collaboration. She completed her doctoral study in that field. We moved on to machine-to-machine communication. Currently, there is one student who I'm supervising in that regard. Then we go on to digital twin design, where I have 2 of my colleagues as well, Mr. Mokalusi and Ms. Lemfani, who are both presenting later today. They were involved in the digital twin design. In fact, Ms. Lemfani was involved in the digital twin design, but from a smart farming aspect. And Mr. Mokalusi was involved in the technology integration, where he looked at the incorporation of blockchains into the smart water bottling plant. I did see a few papers on blockchain and blockchain inclusion, as well as some on smart farming. So it is very nice to see that there are people who are thinking along very similar lines, although we are separated by distance. So we encourage people to come through and have a conversation, or even engage with us. There is something that we can also learn from you in how you go about your work as well. So this is a general outlay of what we are basically doing. I've also been involved with some other projects within the Center for Smart Sustainable Cities, but a slight focus away from SDG 9. This is on SDG 7, where we developed a solar vehicle, and the solar car participated in a international competition. It's a biannual competition where you'll have to take your solar car and run it from one part of South Africa to the other part. Unfortunately, we weren't able to go a very long distance with the car, because theoretically our work was good, but when it came to the practical work, we saw that there was some things that were lacking. But one of the things with entering competitions of this nature is that you get to learn a lot by looking at what your counterparts are doing all around the world. The Dutch team from Netherlands, they were the winners of this competition. There was also some stiff competition from the Belgians as well as the Japanese. So to rub shoulders with them and to see how they work on these projects gave us a lot of confidence going forward. We are participating in the same competition again in June and July of this year. So we're hoping to incorporate some of the things that we learned from the mistakes that we made last time and see how we can actually go on further. We are also involved with the Eurydice project. It is a project that is concurrently run between 3 partner universities in South Africa, as well as 3 partner universities in Europe, one being in Germany, one being in Belgium, and the other one being in Hungary. So the idea here is to give experience to students in the field of renewable energy, especially with focus on solar and wind energy. So there's a lot of exposure that we give there in manufacturing of solar panels, manufacturing of inverters, installation, and the likes of that, so that we equip our students with knowledge of things that will definitely be a huge factor when it comes to our future. So to conclude, we started off by looking at the Sustainable Development Goals, which were set in 2015. There are 17 goals and 169 targets. Of that, as of 2023, many of the goals are lagging behind. So the focus of this keynote address was on the Sustainable Development Goal 9, industry, innovation, and infrastructure. And we focused on how can we upgrade all industries and infrastructures for sustainable growth. Now, we developed, or we showed, a blueprint of how this can be done on a very small scale, with the project conceptualization all the way up to the development of the model. And this was done using the example of the smart water bottling plant that we talked about. So that brings me to the end of the keynote. Thank you very much for listening. Thank you for participating as well. If there are any questions, queries, or comments, I would gladly try my best to answer them at this juncture. Thank you.
Hello, sir. Good afternoon. My name is Bose Joseph. I'm working as a professor of practice at MPITS. So happy to hear about your initiatives for a sustainable future. And just one question: what is the capacity of the smart that water bottling plant, and how many people are being employed? So basically, so how much you have saved in terms of the human capital involvement in the daily production?
Okay. So at the present moment, we have a 100-liter tank. So the smart water bottling plant at the present moment is currently designed for mainly research purposes. But we have seen that we can change the size of the tank to go into a mini or medium scale commercial product. So the tank is structured for research purposes. As far as employment or saving of man hours is concerned, I think it's a topic that will be well discussed, or better discussed, by my colleague, Dr. Kotso, who will be speaking next. But to put it into perspective, we are looking at two aspects. We are looking to see how best a human being can be used in a smart manufacturing environment. So we are not looking to completely eliminate the human element. We are looking at the Industry 5.0 element. So we are trying to see how best a human being can be involved there. So if what was initially going to be an environment where there were lots of human beings involved, either with the bottling or the capping or the packaging section, we can now do a monitoring of all those remotely. But at the same time, we would rather use the human force more effectively and see how best they fit into the project that we have. I think that will be better discussed by Dr. Kotso, who will be speaking next. But I'm not sure if I answered your question, sir.
It's very well answered, sir. Thank you very much.
Thank you.
Hello, Dr. Jandit.
Yes.
I am Professor Johnny Joseph, now charge of principal. Sir, will you please explain once again how, while automated bottling is happening, how they will sense damaged bottles or half-filled bottles?
Okay, so the water bottling plan that we have designed, if I can take you back to that video, that's why I think I rightly explained that if you have a look at this bottle here, it is not completely filled, but the detection is done automatically as to whether it's a 500 or a 330 ml bottle. And once that detection is done, the PLC is programmed to control the amount of water. So it is determined if it is a 500 ml bottle, the flow rate is increased to such a limit that once it reaches the fixed amount, then it immediately cuts down the water. Likewise, if it's a 330 ml bottle, it will again recognize the bottle from the very beginning and only allot that amount of water to the unit. I hope that answers the question, sir.
Thank you, sir.
Any other questions? So my details, I'll share the presentation obviously with Dr. Sajjan as well as Dr. Professor Robin George. So please feel free to get in touch with me either on LinkedIn or any other platform. Obviously, we'd like to have many conversations like this, both with researchers as well as with students, to try and see how we can enhance both our researches going forward. So if there are any queries, it can also be taken offline, and discussions can be held away from this platform as well.
Thank you, sir, for your valuable time and great presentation. Thank you again.
Thank you very much. Thank you very much. Thank you once again. I'd like to thank the organizers, especially Sajjan sir and Robin sir. I think they have been heavily involved in this project for the last 2 days. They must be extremely stressed. A whole big congratulations goes to the entire team as well as the support team. I think they've done a fantastic job putting together a conference of this nature. And looking at some of the presentations that I was able to listen into today, I can see that the quality of research is very high. And next time, if I do get a chance to come to the college, I'll definitely make a turn and would like to see how we can work together in the future. So once again, thank you so much for the opportunity. It's been an honor and a pleasure. And thank you very much for your time.
Thank you, sir. Next section, track for online paper presentation.
Sir, next session is the online presentation. So,
Good
is
day,
that it?
Dr. Kutser. It seems I can't share my screen. Host disable participating screen sharing.
Yes, ma'am. Ma'am, you can share your PPT.
PPT. It does not allow me to share. It says the host enabled or disabled the participant screen sharing.
Ma'am, now you can try.
Now you can try. Okay, there we go. Thank you so much. Thank you. Can you see my screen?
Yes, ma'am.
Yes, ma'am. Thank you. Thank you, Prof. Kyriakos, for introducing our work. And thank you for the opportunity to present here today. The topic that I'm talking about is implementing human-machine collaboration in an Industry 5.0 setting, a case study of an automated water bottling plant. This is just a table of contents, the topics that I will be discussing today. So there's quite a few, so let me get started with that immediately. Okay, so with the constant evolving of technologies in Industry 4.0, it has inspired a new area of study, namely the need to advance human-machine interaction in manufacturing environments by improving collaboration between humans and machines. And this is the core of Industry 5.0, which is the term that refers to humans working alongside robots and smart manufacturing machines. So in terms of decision-making, problem-solving abilities, dexterity, and sensory skills, humans possess skills that cannot be matched by automated systems or devices. So automated systems are totally independent, although human interaction is typically present in the manufacturing process. So the challenge of how to integrate humans into automated systems became a question. Therefore, this research, the question that this study aims to answer is whether there are existing protocols for human-machine collaboration in manufacturing, and if not, how to develop such a generic protocol for Industry 5.0. The methodology applied to this study is through the execution of a single case experiment study making use of the existing automated water bottling plant that was just discussed by Prof. Kyriakos. Just quickly a brief overview again of where my study fits into. The water bottling plant is to generate the bottled water in 330 and 500 ml sizes according to customer orders placed online on a web application. So the orders are kept on the cloud server, and MATLAB retrieves and processes the data to start filling and capping the bottles. So figure 1 here shows the layout of the plant, and it indicates that there are 3 smart manufacturing units that is doing the execution. SMU1, so SMU1 is used for filling the bottles. The smart manufacturing 2 is the capping unit, and then SMU3 is the packager, but that is not part of my current study. So as mentioned, the study will make use of the existing water bottling plant, where a single case experiment will be applied to examine 2 approaches, namely the machine-only approach, where all the decisions are made by the machine. And the second is the human-machine collaboration approach, where the human can intervene where necessary. So the goal of the experiments is to put to the test the theory that human-machine collaboration will contribute to the optimum completion of tasks performed in an Industry 5.0 setting, and thereby also developing a protocol for human-machine collaboration. In the context of this study, the overall equipment effectiveness, or OEE, is used for determining and indicating when the human operator should carry out a task or an action, and when the machine should be in full control. So this is just a brief overview of the OEE used in the manufacturing environment. And the OEE is a key performance indicator. 85% as an OEE score is seen as world-class. However, this study places the OEE at 90%, but we will get to that a bit later. The formula to calculate the OEE for this study is as follows. It takes the good count times the ideal cycle time divided by the planned production time, which results in the OEE score. Here are the terms that's used to calculate the OEE for this study. The planned production time is the total time that your equipment is expected to produce. The ideal cycle time is the time that it takes to manufacture one part, and the good count is the part produced that meets quality control standards. So this is the main formula that will be used. So if we look at the single case experimental approach that has been applied, the goal of the experiment is to prove the theory that human-machine collaboration leads to an optimized production time of an automated system. And to assess the impact of this collaborative decision-making, a human-machine interface, or an HMI, will be designed and attached to Smart Manufacturing Unit 1 and 2 of the plant. This HMI allows for human intervention. As mentioned, 2 scenarios will be executed, and as you can see, maybe it's a bit small. We have the control case, which is the water bottling plant being in fully automated mode, and the test case is where we bring in the human-machine collaboration to test the different approaches. Just briefly, the software tool that is used as the programming for the experiment is the Statistical Analysis Software, or SAS. And as mentioned, the OEE is used for indicating and determining when the human operator should carry out a task or action and when the machine should operate automatically. Another important indicator is the total time to manufacture, or the TTM, and that is determined for each set of custom orders received. And the total time to manufacture can then be used for the comparing of the 2 approaches. Okay, so in executing the single case experiment, as I said, the machine makes all the decisions. And in my study, the constraints that was considered and programmed into the SAS program is the water level in the storage tank, which was limited to 50%. Then the number of bottles in storage, we have 330 and 500 ml, 50 bottles for each. And the number of caps in storage was 100, as both bottles are using the same size caps. Now, the automated system has been pre-programmed to sound alarms when when certain constraints are met. It will be like when the water level or the bottles or caps reaches 50%. Again, at 25%, an alarm will sound, which then has the production to slow down or even stop until all the levels have been replenished again. So the total time to manufacture will be determined for each customer order, and then the OEE score, as I mentioned. In the human-machine collaboration approach, the HMI will be developed to allow the human to get involved in the production process and make informed decisions. The human will be able to stop or slow down or continue the production process by using the HMIs. It's important to note, obviously, the same set of orders will be used to calculate the TTMs and the OEEs for each scenario. The next slide will demonstrate the steps to take for developing the protocol that I have done in the study. There are 8 different steps, and due to time, I cannot go into detail with every single one, but you're welcome to ask questions later. So the first step was to determine the average time to manufacture one 330 and one 500 ml bottle. And so the average time for each customer order could be determined. Secondly, to determine the OEE score, and we have placed the OEE at 90% using the formula as explained previously. And then applying that OEE score to the SAS code for calculating the results is step 3. And the SAS output can then be used for comparing the automated mode versus the human-machine collaboration mode according to the times. The fourth step is inputting the customer orders received from the cloud, used as input to the SAS, and all combinations and constraints have been considered. Step 5 is to calculate the total time to manufacture for the automated approach. And as I said, there are certain constraints that are met, but the machine will stay in full control. Step 6 is calculating the TTM for the human-machine collaboration approach, where the human-machine interface will allow the human to make informed decisions. Step number 7 is then applying the OEE score to the automated and the collaborative approach. And the experiments using the SAS generated the TTM and the OEE score. And then finally, step 8 is the result analysis. And I will get to that in a bit more detail. So we have an outcome of a no or a yes according to the OEE score. So these are the steps that was created to develop the protocol. So next, the results and findings. As I mentioned, the study places the OEE at 90%, which is seen as a good benchmark because the plant is operating in ideal conditions for the specific experiment and study that was done. And the OEE of 90% was coded into SAS to provide the output of the effectiveness of the machine. So the significance of the OEE. So why is that so important? After executing each customer order, a result of yes or no is generated by the SAS code. The no indicates that the machine should continue without any human intervention. So the OEE score will be equal to 90% and above. And then when you get the output of a yes, it indicates that the human should intervene, as the OEE score now falls below 90%. I am going to show you 3 scenarios for customer orders and the results that was found, although we did a lot more experiments on this. Okay, so firstly, scenario 1, We have a total number of bottles from the customer order. The total time to manufacture for automated and human intervention was determined. There's not a big difference between the two. And then you will see the OEE score indicated here is all above 90%. So the result of the output is no, the human should not intervene in the process and the machine can take full control. So it does not mean that the human will always be better. The second scenario is a bit more balanced. The order is larger. And as you can see, the TTM for automated versus the human intervention differs a little more based on the order size. And then the OEE score falls below 90% after customer order B has been completed. So then we get an indication of yes when the OEE falls 90%. So then the human will start intervening. The last one is a much larger order, and you will see the time difference in manufacturing this order is also quite significant. And in this example, only the first custom order could be completed totally by the machine and then taken over by the human. Okay, so in conclusion, the research question that was aimed to be answered was, are there any existing protocols for collaborative decision-making in an Industry 5.0 setting? And if not, how to develop a protocol? As you can see, the results that I showed you, it's the execution of the experiment resulted in the optimization of the plant production process in the Industry 5.0 setting. And it showed that the proposed protocol has the potential to overcome limitations identified by peers in this research area. However, further tests could ascertain the veracity of the protocol and thereby making it an original contribution that can be further examined. And I thank you. Thank you for listening.
Thank you, ma'am.
Thank you. No questions.
So, how will you fix this OE? Is there any change in OE when we conduct more results?
Yes, there is a change in the OEE as more experiments are executed. Like I said, it all depends on the size of the order. And yeah, so the OEE can definitely change. But in our case, we placed the OEE at 90% effectiveness. I don't know, does that answer your question?
Yeah, yes. Can we switch from fully automated to human machine intervention when required?
It runs concurrently. So because the human machine interface that's designed is attached to the smart manufacturing units, the human operator is able to see the status or the overview of the current situation with the system. So the human can immediately see when it should start intervening when the OEE falls below 90. It poses a question to the human operator: should we continue? Should we stop? Should we slow down? So yeah, it runs automatically, but also at the same time, the human has the ability to intervene if it becomes necessary.
Okay, thank you. Any other queries?
Thank you.
Thank you so much.
I would like to remind the rules. The presentation must be completed within 10 minutes and the Viva would be for 5 minutes.
Next, paper ID SA2, Junia Lemfane, on the topic developing a digital twin model for improved pasture management at sheep farm to mitigate the impact of climate change.
Good day, everyone. I'm trying to share my screen. I'd like to ask if my screen is, can you see my screen?
Yes. No.
Is my presentation,
No, ma'am, your presentation is not visible. Can you share the slide? Ma'am, can you share your slides?
yes, please, I'm trying to share. Sorry, I'm
Okay,
trying
ma'am.
to share my slide.
Yes, ma'am. Now it's visible. So,
Okay, is it-
ma'am, yes, it's visible. So, in this conference, 10 minutes time is there, and 5 minutes judges will ask the questions.
Okay, thank you very much.
You can proceed.
Okay. Thank you, everyone. My name is Junia Limpane. I'm from the Central University of Technology in South Africa. So today I'll be presenting the paper titled Developing a Digital Twin Model for Improved Pasture Management at Sheep Farm to Mitigate the Impact of Climate Change. This is basically the overview of the presentation contents. So basically, livestock farming is the largest agricultural sector in South Africa, which accounts for over 40%. Sorry.
Can you adjust your volume? It's not audible. It's not clear actually.
Junia, I think there's something wrong with your mic. Maybe you can just speak into the mic, maybe, Junia.
Okay. Can everyone hear me now?
Yeah, we can hear you. There's a slight disturbance. That's the only thing. I think, is there a moving mic? If you can keep it steady, I think it will be audible.
I'm not moving. Can anyone hear me?
Yes, we can hear you.
Yes,
There's
it's
slight
audible.
noise. Yeah.
Okay.
Let's go ahead.
Oh, okay. So basically, I was saying livestock farming is the largest sector in agriculture, basically in South Africa, which accounts for more than 40% of the output value total, and it occupies roughly 70% of the farming land. So among all the farming systems or farming types, sheep farming is widely practiced in South Africa, and it makes a huge contribution in wool and meat production. Therefore, to get good produce from these animals, farmers need to ensure a good quality and a sustainable feed. Therefore, to utilize this, basically farmers have to have good pastures for them to feed the animals properly. So a pasture is basically a land that is used for production of forage plants to feed the animals. Therefore, it is very important basically to manage this type of land, because this is where the animals basically get their feed from. So smart farming, as the use of technology in farming, has made the management of these lands very effectively by allowing remote monitoring and also tools for weather, to check the weather and soil information, as well as inspecting grazing systems. But however, even with the use of these current systems in place, farmers still encounter some challenge in pest management practices. So basically what the problem is, like small scale farmers really rely on climatic conditions to predict rainfall or any to predict weather conditions. Therefore, it's hugely impacted by climate change. So with the climate change challenges, we see seasons shifting, increase in temperatures, and also unpredicted rainfall. Therefore, this brings a huge variance in weather patterns, which make it very difficult for farmers to manage their pastures properly. So basically, this brings a business collapse. Therefore, if management of pastures are not really in good place, therefore animals will not be able to eat anything. So businesses will collapse, and then people will lose their jobs, and then this is also basically the threat to food security, and this will also impact in the wool exports in our country, as it's a huge industry. So basically, proposed solution for the stated problem statement is that the project will be focusing on the 2 SDGs, which is zero hunger, whereby we will contribute to food security, will ensure that our farmers are sustainable in their production, in sheep production, and also the number 9 SDG, whereby we introduce innovation in the farming sector. So the proposed solution is basically we propose to have a smart system that can provide early warnings about the pasture production to help farmers to make proper decisions beforehand, so that basically this can predict pasture growth, so that they can be able to make proper decisions before anything can happen. So basically it introduces digital twin technology, which is based on the smart farming technology, comprising of AI, artificial intelligence, and also Internet of Things. So basically, a digital twin is a virtual copy of a real life object, of which it mirrors its behavior and states over its lifetime in the virtual space. What basically this means is this is the virtual presentation of the physical object. So whatever happens on the physical object has to like mirror on the virtual platform. So basically, this pairing of the virtual and the physical world enable real-time monitoring of the systems, control, the analysis, and most importantly, which is very important to this study, is they can perform future predictions. So this is basically the architecture of the digital twin. The digital twin will comprise of the physical asset, whereby the sensors will be set up, and then data will be connected from the sensors, and then the digital twin will now be able to make decisions based on the data with using the AI algorithms, which will basically be stated or selected based on their performance. So the methodology used in this research was basically developed divided into 3 sections, which is phase A, B, and C, whereby the phase A was selecting the proper algorithm that can work better, so that we can develop predictive algorithms with the selected algorithm. And then the second one would be the monitoring of the farm, where we set up the sensors to basically collect data from whatever we measure. And then the last one was the creating a digital twin with predicted model, with the predictive models used with the selected algorithm. So yeah, the phase A, basically, as I mentioned, is where we have to select the best algorithm that can predict better. So the 2 algorithms were selected because these ones, the research shows that they can predict climatic conditions better, which is regression and ANN. So to basically build our model, we basically selected our temperature and rainfall data for a decade, so that we can basically have a proper or efficiency of a model of the model. So we selected a decade's data, and then for temperature and rainfall, so that we can check which algorithm basically can work better. Alright, so in the phase A, when the selected algorithm was now chosen, we built what is called a digital shadow. Digital shadow is a first step in building a digital twin. This is basically basing the grounds for digital twin, whether the selected algorithm or the selected models can be trusted in the digital twin. So digital shadow basically was made with 4 models, whereby we modeled this. As you can see, the pasture height is dependent on temperature, soil moisture, and then the rainfall. So we built these models where we can just model or check how much or how can temperature, soil moisture, and the rainfall can basically affect pasture growth. So yeah, the digital shadow was basically divided into 4 different models, which are dependent on each other. So in phase B, we had monitoring, whereby we set up the sensors on the farm. The sensors they included Raspberry Pi, soil moisture, weather stations, basically, and the router to set up as the router gateway for all the sensors. And then this data was then sent into ThinkSpeak cloud. So when we built a digital twin now, since in the previous stage we had to set up the sensor, so that data was now collected and then stored in the ThinkSpeak, and then data was then collected from the ThinkSpeak into MedLab to maybe formalize
me,
our
ma'am.
model in MedLab.
The presentation time is over.
Okay.
Can we conclude? Can we conclude?
Okay, in conclusion, we realize that AN model can perform better based on the presented operations, and then yeah, using all the AN models we have to set up the sensors, data collection, and then data models. We presented the models here. This is the digital twin, basically digital twin results, and then it shows that, well, with the AN model it was basically able to predict better, and then the results were just -4 prediction error. So yeah, the design was successful. Thank you.
Thank you. Now you have some Viva questions from judges.
So what type of sensors are you using? Am I audible?
Okay. Yes, so I used weather station to collect data from temperature and rainfall. And also I used the soil moisture sensor to measure soil. And also I used the chem DSP32 chem to measure my pasture height.
Okay. Instead of ThingSpeak, can you upload the data in any web development, any web application, or any software application, or in any website?
I didn't use any website. I just collected data in real time from the sensors straight to ThingSpeak, so I could be able to access data straight from. Remember, MATLAB and ThingSpeak can work in conjunction or can work basically at the same time. So when you have access in MATLAB, you can basically access data in real time in ThingSpeak.
So it will be better if you import the data into any application.
Application like building an app, maybe.
Yes, app, mobile app. Yes. So you can develop a mobile.
Yeah, I think that one can be as the future plan. Yeah, I can do that.
Any queries? Thank you.
Okay. Thank you.
Judges, please note. Next, paper ID SA3. Paper ID SA3. Lucky Omphomedzi.
Hello, everyone. Can you see my presentation?
Yes, sir. Continue.
Okay. I'm just going to try and... Okay. Is it still visible?
Yes, sir.
My network is a bit bad, so I won't be starting the video. Sorry about that. Okay, let me start.
Yes,
my title is about designing an experimental setup for data provenance tracking using a public blockchain. A case study using a water bottling plant. So I'm actually one of Prof. Kuroko's student. Just graduated recently with my master's degree. Let us start. I will be focusing on the following topics. I will get straight to them. Let's start with the introduction. So basically, what is data provenance? Provenance is defined as a place of origin, which is tamper-proof or its integrity can be verified. So if we look at in the context of a supply chain, it refers to the tracking of the origin and the history of every raw material, process, packaging, and distribution involved in a manufacturing network. The problem of ensuring data provenance traceability across end-to-end supply chain for traceability and transparency is a critical issue. It becomes even more challenging when end users do not have access to centralized storage, making it difficult for them to verify data provenance. This was evident during the 2017 Listeriosis outbreak in South Africa that led to about 216 fatalities because of contaminated meat products that could not be traced back to their origin in time to effect a product recall. Therefore, data provenance is very important, especially in the food processing environment, to know the history and origin of food that we consume So it's becoming to ensure that we have good health and well-being. Data provenance traceability problems can be classified based on the system architecture as centralized and decentralized. The traditional client-server architecture utilize centralized systems. They store data in single storage, making it vulnerable to single point of failure, data tampering, and unauthorized access. This has led to the establishment of what we call the global standard 1 traceability, especially for the food-sensitive sector, which necessitates that all items or products be handled by electronic product code information service, ensuring that an end-to-end traceability framework, irrespective of the underlying technology. Global Standard 1 capture standards are subdivided into 2 categories. As you can see, we have the barcode and the electronic product code, like the RFID, the radio frequency identification. The issues with barcodes, as you can see, they need a line of sight and they are prone to a bad print quality, as you can see there. And then if you look at now the radio frequency identification tags, they don't really need the line of sight, but we have one thing in common between the two, which is data being stored locally on a local database. So how can we address the issue? Well, we can address the issue with decentralized storage, such as blockchain and smart contracts, which can offer solutions to centralization by minimizing the risks of traceability, immutability, and trust. So what is blockchain? Well, blockchain is a decentralized system that uses many computers around the world. Each computer is called a node. Each node can communicate with each other, enabling what we call a consensus. Each node stores a copy of all the data records available on the blockchain. Data is stored as blocks, which are chained together to make what we call a public ledger. Code is stored in smart contracts, which are immutable programs that run the blockchain. So as you can see that table there, the title is about a public blockchain. There are reasons for that because the other two, as you can see, the private and consortium have a drawback because they are permissioned blockchains, and with public blockchain is permissionless. And the only issue with let me say the main issue with public blockchain is the efficiency based on the cost of adoption, as it can be expensive to deploy data into public blockchains. Now, if you look at the water bottling plant, the aim of this research was to design an experimental setup for data provenance tracking using a public blockchain. In this research study, the water bottling plant is located, as Prof. Kurokos has said, at the University of Central University of Technology in the Bloemfontein. So the proposed solution, so we've placed near-field communication tags at point A, B, C, and D. This is mainly just to collect data. Like I said, it's local, but eventually then it's taken to the blockchain. So we have 3 smart manufacturing units, as Prof. Kurokos has outlined earlier, the water filling, the capping, and the packaging units. Each unit creates what we call a critical tracking event, which I then store into the blockchain. So if you look at the overview, like I said, now it is divided into 3 parts, which is the data provenance collection from the NFC tags, and then the data provenance storage, the data provenance storage is divided into two parts, which is the actual blockchain and what we call the interplanetary file system. The interplanetary file system in this case is used to reduce costs, as I've alluded earlier, when it comes to storing data, large data into the blockchain. So firstly stored into the interplanetary file system and then into the hash into the blockchain. So it makes life easier when it comes to tracking the data. So for the data collection, so as you can see the tag, we store data using a tag, and then with each tag has a unique ID where we can now store the number of bottles, if it's a 500 ml or a 750 ml or a 330 ml, and then the date of when the customer actually made the order. So eventually then that is stored as a JavaScript a syntax, which is a JSON structure, and then all that is then sent into the storage, like I said, into the blockchain. The information firstly, it's the JSON structure is firstly hashed into the interplanetary file system, and the hash is then stored into the blockchain. It's stored in a manner like a Merkle tree, which is the foundation of actually blockchain. And then that, when it comes to the tracking, if now the data has been stored in a Merkle tree, we can now use what we call a top-down approach, where we can now go back and forth through the Merkle tree and be able to trace back all the data that was stored. So if there are any anomalies, like a bottle that is not correctly filled, like we saw earlier, we can be able now to trace it back based on the hashes that we have. So in conclusion, the article investigated the broader problem of data provenance traceability with a focus on cloud-based architecture and end-to-end supply chain. The proposed experimental setup ensures that data provenance pertaining to the end user order, raw materials used, timestamp at each stage of the production is incorporated into the blockchain smart contract to make it immutable and traceable. Then this will allow the end user to read the data provenance through a tag attached to the bottled water for traceability and transparency. So this, in conclusion, the results of this study can also be seen as an addition to the knowledge base for broader studies on data provenance traceability, which can reduce the size of a recall from millions to just a few hundred units, highlighting the importance of this research study. Thank you very much.
Thank you.
Hello.
Hello.
My doubt was, can you give some clarity about data provenance? I was not able to understand that term, provenance.
Oh, yes. Provenance is defined as the place of origin. So we need to know the history and where this product is actually coming from. So if you look at now that picture there, we can envision it as the raw materials that made up the ingredients that made up a product. So we need to know exactly where they were harvested, how they were combined together to form a product, or even something that we eat, so that we know, in case like what I've said earlier, when there's a listeriosis issue where a number of people died, then we can now trace back to the origin of who was the actual manufacturer, and then even from there, where the manufacturer actually got the ingredients to put up such a product. I hope it's clear.
Yes, okay. Then how you can maintain the security of this data provenance?
With blockchain already, blockchain is tamper-proof, it's secure, and is trustworthy. And then with the manufacturer itself storing this data that is immutable, it can be trustworthy and tamper-proof. I hope I've answered the question.
Yes, yes. Okay. Thank you. Thank you.
Thank you.
Thank you very much.
That's the end of the presentation. Thank you all.
Hello, sir. Ranjit, sir.
Yes, I can hear you, sir.
Sir, the session is over.
Okay.
Now we are slowly going into the last session of validatory function.
Okay.
So you will be joining in the Zoom meeting.
Yeah,
It will be live.
it's the same link, right?
Yes,
Am I
yes,
right?
yes,
Or
correct, correct. So
yeah,
for some 10 to 15 minutes will be there for arrangement.
no problem.
Okay,
I'll be
thank you, sir.
online.
Okay, sir. Okay.
All the staff and students are requested to assemble at the entrance for a photo session. And you can have your tea. And at sharp 3:15, we will be beginning the valedictory. To improve the golden moment of opportunity and catch the good that is in our reach is the great art of life. A very warm good evening, galaxy of intellectuals, invited guests, professors, students. On behalf of the institution, we are delighted to offer a gracious welcome to all of you. SPICE 2K24 aims to bring researchers, academicians, industrialists, and students together to offer a platform that delivers the most recent developments and trends in the field of engineering and technology to meet sustainable development goals. Now, it's the last day of SPICE 2K24. Here we begin the valedictory ceremony with a silent prayer. Now, I invite Assistant Professor Shiny Peter of Electronics and Communication Engineering Department to give a red carpet welcome to everyone gathered.
Good evening to one and all. Distinguished guests on and off the dais, my dear colleagues and my beloved students. So today we have come to the conclusion of two-day conference SPICE 2K24. First of all, I would like to take a moment and congratulate all the faculties and students who have contributed in every way to make this event a grand success. So pat your shoulder yourself, we have done it, okay? So moving on to my responsibility, I would like to invite our beloved principal, Professor Johnny Joseph, sir, to this gathering. Welcome, sir. Today with us, we had Dr. Ramu R, Associate Professor of Adi Shankara Institute of Technology and Science, Kalidi, who served as a distinguished reviewer for our sessions. Welcome, sir. This conference is jointly financed by MPETS and BUS. We have Joint Director of BIS Chennai branch, Sri Srijit Mohan J, with us. Welcome, sir. So every event is actually a joint effort by a team of people. So the team of people today here for the last 2 days or last 1 week was our technical staff, non-technical teachers, our housekeeping staffs, and you, dear my students. So I welcome all of you together to this event. And this whole team is, or a whole bunch of faculties and students are led by two of our favorite persons in the department. One is Dr. Sajjan CS, who is the coordinator of the event, and the other one is Professor Robin George, who is the co-coordinator of this event. I especially welcome both of you to this conclusion day gathering. I welcome all of you. Thank you.
Thank you, ma'am. I would now like to invite our respected principal, Professor Johnny Joseph, the sculptor of human character, to address the gathering. May I take the pleasure of inviting our principal.
Good evening, all of you. Now, it is a very happy occasion that our department, ECE, conducted this international conference in a very fruitful way and in a wonderful manner. I first of all congratulate the organizers, the staff members, and all the students of ECE department. And we are honored with many dignitaries, especially from BIS, scientist Srijit Mohan, and also our associate professor, Dr. Ramu. They were always with us in organizing such events, and it was very fruitful. I thank all of them on behalf of our MBITS College. And also, you have experienced the informations given by many dignitaries during this time. And it was a pleasure and informative because of organizing and experiencing the cooperation of all members. Especially, I have to mention, and I am happy to mention, the cooperation of the students of ECE department. Congratulations, all of you. And this was a platform for sharing the informations gathered for the researchers, and they have got a platform for presenting their research thing. And I appreciate and thank all the participants, those who have presented their papers in this function. And not only enjoying the informations and gathering information. You might have experienced a lot of things by organizing such events. After becoming engineers, I have to say you should know this importance of cooperation and sharing. When you are going to an institution or an organization, an individual work may not be fruitful. Teamwork is very essential. Now you are learning a lot of things regarding these basic things. So you have to understand whatever drawbacks might have happened during these 2 days. We cannot say 100% it was efficient. There will be some small drawbacks, and understand those drawbacks, and next time that must be inspiring for us to correct all those things, and again we can conduct better and better programs from our department ECE. And also it will help or motivate other departments also of MBITS to conduct such wonderful things. It was really wonderful, and it was appreciated by all of the people from our college and also from outside that we have conducted this program in a wonderful manner. This was not because of a single person's effort, especially because of the Dr. Sajin, Robin sir, teachers, and all the students together. And we have worked hard and conducted and come to a conclusion and concluding this program in a fruitful manner. So we can conduct many things. This is a curtain raiser program. So I appreciate once again all the students, staff, and the dignitaries, and wish you all the best. Thank you.
Thank you, sir. Now let me take the pleasure of inviting Dr. Ramu R., Associate Professor, Adishankara Institute of Technology and Science, Kaladi, for the valedictory speech.
Respected dignitaries on the dais and off the dais, it is very difficult to conduct a conference, especially international conference, especially during this short time span. So first of all, I congratulate all the team, especially the management of MBITS for conducting this, for successfully conducting this conference. I think this is the second conference, so we are expecting the third conference in the next year, and in this case, in this conference, for the they got only a short time span, although they they got many papers during this time span. So that was a very great success, and it was a very great effort of the entire team. The vision of the principal, then EC department, HOD, all the faculties, especially the coordinators, Dr. Sajin CS and Robin George. They have wonderfully conducted this conference, international conference, and they have conducted in the timely manner. And I congratulate all the team members. Also, I congratulate all the student coordinators those who have supported this conference. Then in the next year, we are expecting more and more papers, and also from our college also 3 students presented the paper. So that was a very good opportunity for them during their BTech duration that we don't get during our BTech study. So they presented the paper, and they were very happy that they have presented a conference paper in an international conference. So while presenting the paper in an international conference, you can share your ideas. So you also get other informations in the related areas also. So I also telling the participants that next time when you when this conference is conducting, try to publish papers in this conference, right? So once again, I thank all the members behind this conference. Thank you.
Thank you, sir. Now I would like to call upon Sri Srijit Mohan J., Joint Director of Chennai Branch BIS, for concluding remarks.
Good evening, all. So, how do you feel after these 2 days of conference? What have you learned? That actually your feedback is more important than what we are saying from our side. So that is one important thing. So one thing I was always noticing was how you were saying international conference. So what difference did you find from the presentations what saw online from I think South Africa, right? Free State. So from their presentation and your presentation, what difference do you feel? Did you have any takeaway from that? They have taken a very simple subject. Most of the people have taken a simple subject, a packaged drinking water plant, automated plant, very simple plant. One bottle they were filling it. But from that, how they prepared that paper, it was in a structured manner. That is more important, how you present things. Even though the thing is very simple thing, which can be maybe presented in a 1 or 2 slide, but they have identified a problem statement. How they presented it as actually it's a very important thing to notice. So whenever in future also you participate in some conference, you have to present a paper. You have to take into account how you present the thing, how you can give it, how in a structured manner, identifying the problem, what is the solution, and in a formal manner. So I hope that everybody who has participated, who has presented a lecture, and who has not participated also has gained something out of this conference. And as Team MBITS, actually, I would like to congratulate each and every member of EC department and the entire team of MBITS for the smooth conduct of this conference. And I'm very happy to be part of this conference on behalf of BIS. So thank you for having me here, and all the best for you guys.
Thank you, sir. Now we have a feedback from participant. I invite Rihanna of St. Joseph College, Pala, for a feedback.
Good evening, everyone. We are students from St. Joseph College of Engineering and Technology, Pali. So firstly, thank you for MBITS for giving us this opportunity. So it was a great experience to able to showcase our project in front of such a good panel. And we believe the reviews and feedback we got from here would help in our implementation and further processing of our finally a major project. And thank you, everyone.
Thank you. I also invite Manju from St. Joseph College of Pala for a feedback.
Hello everyone, I am Reina Raj and thank you so much for this wonderful opportunity, and thank you so much MBITS, and we'll definitely have some help from this conference during our project implementation and during the major phases in our project. Thank you so much.
Thank you. Now we have certificate distribution and bus paper award. I invite Dr. Ramu R, Associate Professor of Adi Shankara Institute of Technology and Science, Kalari, to give away the award. First, participation awards. Binsu Vidas of Rajdhani Institute of Engineering and Technology. Alex Saujin of Ma Baselios Institute of Technology and Science. Kavya Biju of MBITS. Alvin Joseph of MBIT. Alan Thomas George of MBIT. Amrita MU of MBIT. Manjushri Ravindran of St. Joseph College of Engineering and Technology, Palai. Reina Raj of St. Joseph of College of Engineering Technology, Palai. Abhirami Aji of MBIT. Now I invite Sri Srijit Mohan J, Joint Director, to give away the awards. Abhijit Rajendran of MBIT. Dilip Kumar A of MBIT. Helena Jaimon of MBIT. Badusha Ali of MBIT. Appu Subramanian of MBIT. Basil Paul of MBIT. Now I invite our respected principal, Professor Johnny Joseph, to give away the awards. Asrida Sadanandan of MBIT. Nitya VS of MBIT. Nandana AV of MBIT. Steve Manuel Jami of MBIT. Safa Subair of MBIT. Anjali Jain of MBIT. Now it's the time to announce the Best Presentation Awards. Miss Manjushri Ravindran and Miss Reina Raj got Best Presentation Award from St. Joseph College of Palay. Congratulations. You're awarded a certificate and a cash prize. Another Best Presentation Award goes to Dilip Kumar A of Ma Basilios Institute of Technology and Science. Another Best Presentation Award goes to Nitya VS of Ma Basilios Institute of Technology and Science. Congratulations to all the participants and winners. Now I invite Professor Johnny Joseph, Principal of MPITS, to give away a memento to Dr. Ramua, Associate Professor, Adi Shankara Institute of Technology and Science, Kailadi. We also have a token of gratitude to Srijit Mohan J, Joint Director of Chennai Branch BIS. His immense presence for last 2 days. Thank you so much, sir, for your presence. Now I invite Dr. Sajan CS, Coordinator of SPICE 2K24, to deliver a vote of thanks.
Respected Principal Professor Johnny Joseph sir, BAS Joint Coordinator Srijit Mohan sir, Associate Professor of Adi Shankara Engineering College, and my friend Dr. Ramu sir, Dr. Ranjit B. Kuriakose from Central University of Technology, Free State, South Africa. As we come to the conclusion of the remarkable international conference on signal processing, instrumentation, and communication engineering, I would like to take a moment to express my sincere gratitude to each and every one of you who have contributed to making this event a resounding success. First and foremost, I want to extend my deepest thanks to our distinguished speakers, especially inaugurator Dr. M.V. Rajesh sir, BAS Joint Director Srijit Mohan sir, Dr. Thomas George sir, Dr. Binu VP, Dr. Ranjit B. Kuriakose, South Africa, and Dr. Ramu. I want to express my gratitude to the panel members and attendees who have participated in the discussions, asked thought-provoking questions, and engaged in meaningful exchanges of ideas. Your active participation has been instrumental in creating a dynamic and intellectually stimulating atmosphere throughout the conference. Last but certainly not least, I want to extend my heartfelt appreciation to our department. Irrespective of whether you are a student or a teacher, we stand together. Once more, we prove that unity is strength. Irrespective of the roles we assigned on us, but we work together without no ego, and together we reach in a stand that the international conference a success one. Thank you all without saying any name, especially our principal Johnny sir and our HOD Sharon Miss and all department and organizing coordinators and students. I will thank all of us. And from other part, that is management part, they give maximum support and financial support along with BAS. So once more, I would like to thank all of us who stand behind us to make this a grand event. Thank you. Thank you all.
Thank you, sir. Once again, a special thanks to Sri Srijit Mohan sir for financially supporting us and for having your support with a pleasant face for the whole today. Thank you so much, sir. On behalf of BIS, now we are coming to an end. We can end the session with the national anthem. For the same, I invite the college choir.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष माहे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
We arranged tea for you. You can have it. And thank you.